Hey, welcome everyone. Thank you for joining us today. We are officially live.
Yeah.
It's been quite a while. You know, I was looking at our last time we went live, and it was almost exactly 3 years ago.
3 years ago?
So it's been over 3 years.
Long overdue.
Whew. I apologize in advance, guys. They are currently plowing our parking lot outside. We got some wonderful winter weather
Yeah,
today.
we got a little bit of snow going on out there, so there's really nothing we can do about it.
So it might be a little bit noisy here for the first few minutes as we're going about this today. But as the title suggested today, we are covering some myths related to spark plugs and ignition coils, and maybe they're correct or maybe they're not.
Just some statements that a lot of people make, or maybe just think are correct.
Yeah, so we're here to kind of prove it out, but in a controlled environment, because on a car, spark, ignition, all of that is a very
erratic
or dynamic event that happens. So we have some testing equipment here that we're going to show you guys in just a minute on what we're going to be using as our control for this experiment. We got 6 boxes here in front of us.
Yep.
With our mystery myths inside of them.
Mystery boxes.
Just want to check in on the chat quick. Can everybody hear okay? No complaints of audio issues, so I think everybody can hear us all right. Now, when we're sending out emails and stuff related to this thing going live, I mentioned that we are giving away T-shirts. Ryan, can you?
Yeah, we got some of these T-shirts right here. Here is a one with a wrench.
That's the pocketed T-shirt.
And the pocketed one. I believe we got another one down here. Okay, we got the non-pocket with a nice little engine on the back there.
Awesome. So we're giving some of those T-shirts away today. We're going to give some away throughout the broadcast here, but we're going to start off with the giveaway related to people who signed up for our mailing list. If you haven't already, you can head out to gotech.com/sign up to get registered to receive our emails. That way you know when we're doing this kind of stuff. So I said that we would give a shirt or two away related to that. So I have up on the screen, I think it was 60, we had 63 entries who who signed up for this. So let's see what happens here. Let's click the spin and see who our lucky winner is.
I'm kind of excited for this, actually. Let's see what we got here.
So our first winner is, I thought it was going to be Paul, but it looks like it's Luis Jr.
All right.
So Luis, shoot me out an email. I'll put my email in the chat right now.
Congratulations.
Here we go. And we'll see if that works.
Make sure you email the size and what type of T-shirt that you want, if you want the pocket or the non-pocket T-shirt
exactly.
also.
Yep. All right, so we're going to go ahead and we're going to remove Luis from the list. I want to give away another one. Let's do 2.
Why not? We haven't given away any for so long. Might as well just start shooting them out, huh?
Yeah,
Let's
been.
go.
I wish we had a T-shirt cannon. That would have been way more fun.
I feel like I see a couple names on here twice. I don't know how that happened, but.
All right, up next we have Michael. Congratulations.
Congratulations, Michael.
Again, my email address is in the comments, and if you guys see me constantly looking over here, I got another computer over here running the live stream.
Yeah,
so
there's quite a bit going on that, so we'll try our best not to mess this up.
A lot of things happening behind the scenes, but go ahead, send me out an email as well, Michael, with your T-shirt size, and if you want one with a pocket or without.
And it looks like we got him on the chat too. Welcome.
Awesome. Sweet. All right, that is great to see. All right, so I think we can get right into it. I think we'll just do 2 of those for now, but we'll give some more away later on. But everybody who is live in the chat right now will have an opportunity to win.
Yep.
You will have to be able to chat in to win those. So if you're not currently signed into YouTube, you're not going to be able to chat. So go ahead and make yourself a YouTube account really quick. That way you can chat with us, chat with the group, and
get a chance to win that T-shirt.
Exactly. Okay, let's dive in. So today we're tackling these facts and these myths about these spark plugs. Let's get these out of the way so everybody can kind of have a better look at what we're doing here.
Get these high-tech cardboard boxes out of here.
Well, you know. So sitting here is what looks like a menagerie of lab equipment, but really what we've done here is established an ignition system off of the car, right?
Well, technically 2 ignition systems, but yes.
True. 2 ignition systems that we can get a consistent output from, right?
Let's talk about this one first, huh?
Okay, the one in the back here. You want to give them a close-up shot?
Yeah, why don't we give them a shot of what we got in? Otherwise they're going to be wondering the whole time what we have in the box here. And let me just get some more. So inside here, we're going to open this up here.
You guys should be able to see.
So what we got here is a oldie but goodie GM HEI ignition coil. And if we look down here, it's a slightly modified GM ignition module. And I really couldn't tell you what all of this does, but pretty much what it is it's a setup, so it puts out the same amount of on time or same amount of spark all the time.
Correct. So actually, let's get a shot of this test specification on the front here, just so everybody can see exactly what we're going to be testing at, and I'll show you guys.
If we can get down
is it going to work?
Here. Let me just try to.
There we go.
Okay.
So we're going to run a 30-second cycle on this. So when we power this thing up, hit the start button, it's going to fire a spark plug right to here for 30 seconds straight. And we're going to run all of our tests today on low, just so we have a consistent reading. But it'll fire a 30-second window at 100 hertz, and we're going to measure and use that as a consistent
The big thing here
baseline.
is that it's going to be consistent every time. So most of the tests we're going to do, as long as it's consistent, we will be in the right area.
Exactly. And let's show them this guy as well. We don't have to turn it on right now. But
okay, so what we have here is we have a signal generator. And this is pretty much going to act like the PCM. It's going to give a signal to what we have here. We might actually want to show them this quick. So what we have here is we have two GM ignition modules. And these are going to be firing two different coils at a time when we see fit here. But this box right here, this is what's going to give it the signal or the PCM command to fire these ignition modules here. And everything else on these is wired pretty much normal, just power ground, and then the negative to the coil.
So the main factor here with any sort of experimenting that you do, you want to make sure you have consistent testing to make sure that everything that we're checking today with these myths is going to be relatable. So this box here is going to send a signal to establish 100 hertz, same coil on time when we're firing our coils in this rack, or they're being fired here in this pressure
chamber. And these ignition
chamber.
modules are exactly the same too. So
exactly. So same outputs. We just don't have the ability to fire two spark plugs in our pressure chamber at a time. We can only fire one. Now this is a pressure chamber.
And I think this is what actually makes it cooler than just firing a normal plug, right?
It's more real, right? Spark plugs fire under compression. There's that squeeze inside of the cylinder. The spark plug is going to fire there, and we'll get into what that pressure does here in a little bit. But we're going to be able to pressurize this thing up to what our shop air pressure is, about 100
psi,
which really isn't too far off of a running
at least
idle.
at idle.
Yeah, a running compression at idle. If you guys are familiar with running compression waveforms, let me give you guys a close-up. You'll see here that this is out of a Ford Escape with a 2.5 liter, but you can see our running peak compression on a cylinder that's not firing is this one at idle, warm, is about 71 psi. We take that to another end of the spectrum. We do a cold start idle on a Mazda 3 with that 2-liter Sky Active motor.
And this one is very surprising. I almost didn't believe it when I first seen it.
Well, they're doing some crazy valve overlap things happening on these Mazda 3s at cold start idle. It's amazing that this is from a running engine, but that's 300 psi. So we would expect to see some pressure differences based upon RPM of the engine, but we're going to test today at 100 psi. So 100 hertz frequency on the testing machine, running a coil inside of here to a spark plug here, or our ignition control modules running coils here.
Yep.
But all of our tests will remain consistent. We'll draw out those variables when we get to each.
And there's a couple of variables
test.
missing, but they're missing on purpose. Like, we're not going to use. Obviously, there's not going to be hydrocarbons involved. We don't want to blow anything up today, and but actually, this is going to make it more consistent and give us readings. I think that are going to make our tests more valid. Yeah,
fuel is a variable that we can't really mess with today. Unfortunately, no. I mean, we could do it on a car, but then there's a million other variables that would.
We don't have the right safety equipment either to do anything like that. So
not that we tried. All right, so just check and make sure. Will Dr. Frankenstein start the spark? All right, let's draw a baseline here. Let's get a plug put in here.
So since we're going to be making spark, what we're going to do, and what most of our tests are going to be off today, is we're going to do secondary ignition measurement or a secondary ignition waveform measurement. We're going to be using a scope, and we're going to be using a secondary pickup, a clip-on pickup.
I was just clicking the torque wrench.
Oh, clicking the torque wrench. Okay. And we're going to be using a secondary pickup, and that's what we're kind of like we're going to do for most of our testing today.
Now, secondary waveforms are maybe not something that a lot of people are capturing anymore these days. I mean, we're dealing with, why don't I have a coil sitting here? I guess we're dealing with coil on plugs today, and it's kind of hard to gather a secondary waveform on modern ignition systems. But if you get yourself a set of jumper leads like this is essentially a glorified spark plug wire. But what we're going to be doing today is hooking that into our ignition coil, and then we'll be hooking that onto our spark plug. So we have a measurement area, just like you could do on a car if you're dealing with coil on plug ignition, trying to capture a secondary waveform.
And if you're using a scope, you could always go at primary too. It's going to be very close to secondary, but since we can get secondary, we're going to use that today.
Exactly. Now, I understand that not everybody knows what a secondary waveform looks like, what it's going to look like to capture, what it all means. So we're not going to sit here and teach every aspect of the secondary waveform.
No, we're just going to kind of show you what the major things that we're going to look at today when we do our test. So let's get one of these fired up here, and we'll kind of just explain the big ones that we're going to look at here today.
So I've just set the scope up for channel A to capture our ignition pickup. We're going to run an inverted signal. We're going to put it up to about 10 kV and see where that's at. I'm going to go ahead and up our scope capture rate because we want to capture as quickly as possible. And let's capture a little bit more time.
Let's get this thing turned on here.
You just turned it off.
Okay, so this thing's off.
Power's on. Everybody's on. Now we are going to move this this pressure chamber up to 100 psi. So on our gauge right here, see if this works. So you guys will see we're filling up our gauge, and that's 103 psi.
I don't know if you guys can see this, but it's right about 100 psi we're at here.
All right. Well, fire in the hole.
Yep.
So we are creating spark.
So it's working.
It's doing what it's supposed to. Let's grab a little less time and let's throw a trigger up here. Again, this is going to run for 30 seconds. Run an auto trigger. And there we go. It's dancing all over. We are actually getting channel overages. So we're getting channel over at 20 kV. So this thing's taking a ton of energy to jump that gap.
And remember, we're running this thing pretty lean, so you're going to get a lot of kV.
True. No hydrocarbons at all in there. Let me run it one more time so I can pause this. Actually, let's see if we got enough here. There we go. Okay. So what we're looking at here, Ryan, you want to
why don't we just kind of explain this a little bit here?
Just so that everybody can kind of follow along with us today when we're talking secondary waveforms. That one's a little bit ugly of a look here, but it gives you enough to talk about. Go for it.
Let's switch this camera view out here once so they can see me here.
There we go.
Now, some of you guys already might know this, but we're going to start here. Now, this line is going to be more of our basis line, or our basis voltage line to our coil. Now, when you see this voltage drop here, this is going to be when the coil's energized. It's kind of like when the points are closed on an old car, or when the ignition module energizes a coil. And this is when it starts energizing. And this little ringing here, it's normal. We're not going to get too much into that today. Now, when you see here, right before it goes up, this is going to be the total on time of our coil. And we're right about 2 milliseconds, and that's where we're going to do most of our testing today. Now, if you look at this big shoot up here, this big spike, this is going to be where the spark jumps the gap of the spark plug. It takes that high kV to get past the gap.
So that's the energy required.
That's the energy required to jump the gap. Yep. Now, you see this little down here, and I like to call it almost like a bridge, because what happens is once it jumps the gap, the spark that goes across the gap almost creates like a bridge for the spark to flow, and that's why it's at a lower voltage. And we consider this like the burn time, and that's going to come right up to where this hump is here. And then we have kind of, let me move out of the way, I might be here. We kind of have like this little squiggle at the end. That's just like coil dissipation, and there's a lot more you can interpret on these, like I said, but we're just going to kind of look at this normal stuff today. So we're looking at the coil on time,
which is 2 milliseconds.
Which 2 milliseconds, yes.
That'll remain consistent to our testing.
And then we have our high spike and our burn time, and those are going to be the 3 main measurements that we're going to be looking at today.
So we're going to refer to them today as I guess as firing kV, what's required to fire the spark plug, and then we're going to refer to it as burn time. So if we're taking a measurement here, we're at 1 millisecond of burn time, and we had a 2 millisecond on time for the coil. And
these aren't going to be comparable. A lot of the tests aren't going to be comparable to a real car because like I said, we're firing a dry chamber here. It's
incredibly lean.
But it is going to be very repeatable. It's going to be a good control.
Yep. So we got about 30,000 volts to cross the gap of the spark plug. It burns for about 1 millisecond after the coil being turned on for 2 milliseconds. So that's our baseline here. Now every test we do from here, will be based upon those principles. So,
here we go.
strange accent. Oh, Glenn. We're all, I mean, we're not Yoopers here, but you know, being from Wisconsin, we got that accent.
I don't hear it.
All right, let's get into. Should we get into the first one? You got the box?
Yeah, let's get into it. What do we got?
A little bit of a drum
here?
roll.
Number one.
Number one. The myth is spark plug gap matters.
And what do we got in our box here? Three spark plugs.
Don't drop your spark plugs, by the way. Don't
Yeah,
worry. These aren't
maybe
going.
treat them better than I did.
These aren't going into an engine at any point.
But these are three exactly the same spark plugs too.
So we got identical spark plugs. Does spark plug gap matter? What do you guys think does... Oh, there's Keith. Thanks for the 99 cents, Keith. Are you not on board with where we're at so far? Or is that an interested face? I'm not sure what the emoji's for.
So it's more of a question, I guess. He says not a myth. A lot of these are just going to be statements. And does spark plug gap matter? And
Well,
does it matter?
What can we do here to prove it out? So we can start with the specification.
And
right?
we're not just thinking like, does spark plug gap matter, but how much does it matter? I mean, some of these gaps are 30 thousandths. What if you go to 50 thousandths? What if you go to 10 thousandths? Is it really going to create that big of a difference to matter in the ignition system? You know, I think there's only one way to find out, and we can do that today because we have such a good control.
All right, I'm going to take the pressure out of here.
We have a lot of yeses, and I think I'm on board with you guys too.
So we got 3 different tests here. So we can run an OE gap. We can run, let's call it a small gap.
Smaller gap, and let's go big, and
large.
let's see what the actual effect is on the cylinder. And what I'm really excited about is we have a good control, so we should get some pretty good results.
Right. So let's pull firing KV.
So this is going to be how much it takes to jump the gap.
And we'll have to do an average because it's not going to be perfect, but we'll be able to kind of do an average of firing KV. And then we can measure burn time as well, and we can see what the effect gap has on those things.
So let's start with an OE gap. And what do we have for a, what do we got for a gap on there? These are 44 thousandths is the factory gap on this plug.
Okay.
So let's just check to make sure, because how many times have you opened up a new spark plug and the gap was smashed down or over big or oversized? So I'm just going to check this just to make sure that it's got that factory gap.
Yeah,
here.
I'd be a little bit worried. If the gap were smashed down, it was likely dropped, right? I probably wouldn't install a drop spark plug. Not a good idea, but...
So surprisingly enough, this is right about 44 thousandths. So
perfect.
Let's get that thing in here and use our approved installation method here.
Again, these aren't going in an engine, and we're going for speed here, so we're using the impact. And the calibrated elbow torque wrench, right? Click, click.
We got some pretty good comments here, too. I'm just checking out the comments here. Looks like a lot of you guys know what you're talking about. That's cool.
All right, so we'll get the scope out. We'll get it live.
Okay, and this is the normal gap, 44 thousandths.
So we'll bump our pressure back up inside of there. 100 PSI, a little over 100 PSI. And fire in the hole.
Yeah, see what we get.
So it looks a lot like our control did. You want to give them a close-up of that spark? I think that'd be kind of cool.
Show them that this thing is actually sparking here. It's pretty cool to see, actually.
Nice.
Ooh, let me see if I can get in here. Ooh, a little too far away. Okay, there we go.
That's cool looking.
Kind of little.
All right, I'm going to pause the scope so I don't lose that capture. All right.
Okay.
So when this time's out here, let's do just our base measurements again. So we're at this capture grabbed, call it, let's just round to 25,000 volts to jump the gap.
That's a big gap.
and again, we're running super,
and if
lean.
you're a scope guy, you already know these are higher than you'd see. But when you're running dry, you're going to get some pretty high.
Yeah, there's no hydrocarbons in there to bridge the gap. And then we're going to put the burn time measurement right at the peak of the excess energy there. I think that gives us a really consistent point to measure there. So we're at 1 millisecond.
That's not bad.
1.09 milliseconds of burn time with a 25,000 kV. So our OE gap had a 25K, and our burn time was 1.09 milliseconds.
So we're going to do small gap next.
All right.
I'm not going to be too precise here. I'm just going to, I'll measure it though. Let's get this pretty small once and see how this affects it.
Ooh, we should let the pressure out.
You could shoot a plug up in the air. They'd like to see that. Why not?
Don't remove spark plugs under compression. All right, where are we at?
Oop.
Tiny?
Go a little smaller here. I'm just trying to be careful. These are hard to gap, these precious metal plugs here. Okay, so this is, I'm going to go a little smaller.
Frank, gap is determined by cylinder pressure and air-fuel ratio. Definitely.
Yeah.
The leaner the cylinder.
Okay, so this, sorry. This is probably about half of what the gap is. I would say it's about 20 thousandths when we measure it here.
Okay, so I'm going to write that on here just so we remember. Whoops. I'm using two different
It was a pretty
keyboards.
strong. I didn't want to close it completely by giving it too much here.
So 20 thousandth gap.
Get out your fancy torque wrench there. All right, this is what we really can't forget to hook this up, or it'll be a rough day for both of us.
There's nothing better than electrifying your metal cart that's holding everything as your legs touching against it.
Okay, so let's get our pressure back in there once.
All right. So we're good there. We're good there. Let's fire off the scope and get it back to live. Here we go. Let's also clear the cursors out of there. So now our gap is smaller. I predict. What do you predict?
It should be a lower KV, right?
Significantly lower.
Wow. I mean, I was expecting it to change. I didn't think it would change that much.
Cool.
Very cool.
Okay, I'll pause it there. And let's just zoom in a little bit on it. So now we're looking at, what do we got here? 10,000. We'll call it 10.5.
It looks like we're getting a lot of questions of measuring coil amperage. It was definitely on our list. It's just really hard to get inside that testing box with when it's firing.
Oh, definitely. Yeah, everything inside of there is shielded. We do have amp clamps sitting here. We could grab coil amperage when we're firing off of
Yeah,
our,
we'll grab some amperage for you guys when we get some of the other coils firing.
So reduced KV, 10.6, but our burn time now is a lot higher.
Look at that burn time.
2.16. All right. So small gap, 10.6, and burn time of 2 point, what did I say it was? 2 point something.
I think you said 2.16.
2.16.
That's significant.
That's.
I mean, it was a pretty small gap, but I mean, it wasn't touching. I've seen worse. I've seen worse come right out of the box when I open these things up. Okay, so what's next? Large gap. All right, let's fire this thing up once.
Now let's try to not make it too large that we end up with essentially an open secondary.
Another question for you guys too. Are you guys all checking spark plug gap? I mean, I know a lot of guys that just expect them to be good out of a box, right? I mean, some of them even say do not gap, but they're not always correct, right? Like,
right. And not every plug out of the box is going to be the gap specification for the vehicle. All right, let me not mix these all up here. Here you go. So where are we at now?
All right, so we're gonna go probably about twice the size here.
And
yes.
Matt, yes, we are recording this, so after today's lesson, it will be available as a recorded event, so you can come back and watch it anytime you want. All right, move
Looks
fingers.
like everyone's checking the gap, which is definitely good. And yeah, good idea too. Make sure you use the right tool to gap these things. You want to use something where you're not touching the precious metal and definitely not bending it in the wrong spot.
All right, we are pressurized. The lead is on.
And I would say this is probably about a 70 thousandths gap. I went just a little under twice.
70-ish.
Yeah.
All right, here we go. Fire in the hole. Ooh, it even sounds different. Ooh, can you get a close-up shot of that?
Let's look at that. This is not making it very happy.
So we got inconsistent spark at this point.
You can actually see the spark is not even hitting the electrode all the time.
It's grounding to the shell of the plug. Oof, that's ugly.
Maybe we went a little too big.
So our gap is a little excessive here. And our lab scope is showing that. All right, I'm going to go ahead and pause the scope. And I don't know if there's really much to measure here. Our KV is going to be surprisingly not all that high in the KV, but I wonder if that's because we're running into an inconsistent spark.
Yeah, from looking at that, it looks like the higher gap actually caused what we would consider a misfire.
I mean, this is an ugly looking pattern. I mean, is this is that a point 0.16 millisecond burn time? I mean, are we looking at the extra energy here? What do you think?
Yeah, I mean, I would say this is a little inconclusive because we made it too big, but yeah.
So we went with a large gap and caused a misfire, essentially. So, I mean, I guess I'll document it at 27,000 volts. Pull up the right thing here. So large gap, 27 kV. Let me just, let me see if that's, I mean, it's pretty, across multiple recordings here, it's pretty consistent at that rate, somewhere between 25 and 30. But that burn there is ugly.
But yeah, it definitely matters. I would say that it's definitely created some issues.
Definitely. So I guess we gotta get to the end here, and
I mean, most of you guys already knew, and I mean, we knew that spark plug gap was going to change something, right? But let's kind of talk about, I mean, what's better, right? I mean, so we had a lot of good comments on here that kind of explained, you know, the gap would be higher kV with a bigger gap, and we got smaller burn time. But when we went to a smaller gap, we had lower kV but larger burn time. Mike, what do we want here?
I mean, it's kind of, it almost turns into like a trial and error type of thing. I mean, there's a reason why the engineers who designed the spark plugs to fit into the engine for the specific air-fuel ratio, specific cylinder pressures, specific temperatures. I mean, there's a reason why those engineers spend so much time, money, and effort on developing the spec for the spark plug.
And one thing we talked about before too is if you get a bigger gap, you're going to get like a longer field of electricity, and that can be the plasma channel. Like, so the gap, you're going to get maybe more surface area to light your cylinder. Okay. But the problem with that is you're using so much kV to jump the gap, and now you could compromise burn time, which is going to be a misfire, right?
This is kind of where that string theory comes in.
And then if we have too small of a gap, we really don't have any issues of jumping the gap, but then we maybe don't have enough plasma channel or something maybe to light your cylinder.
So it's like an effect of the surface area between the spark plug electrodes. The larger the surface area of the plasma channel, essentially, the larger the explosion can be from the get-go, creating a more complete combustion event.
So yeah, so maybe
if we shrink the gap down.
Yeah, so we could talk about our string theory that we were talking about before here.
I don't think we have a good pattern right now.
We don't have a pattern, but we could draw something out here.
Well, we could swap this plug back out quick.
Yeah, let's swap this plug back out and let's get a good pattern here once, and we can talk about that.
Yeah, because
you got him over there for you.
I think that one will work. So you can kind of talk about that string or that rope theory.
A little small. Bring her back to what looks like normal.
All right.
Close enough, right? Oop.
Let me just make sure it's tight so we don't have an air leak.
Click, click. All right.
All right.
So let's get another pattern up here once.
Scope is trying to get live.
Ooh, point of plasma. Now we're getting some good questions.
All right. That's a pretty clean pattern. Let me go ahead and zoom in on that. There we go.
Okay.
And you want to hit the board. Okay, so you got it so we can draw on the screen. Go for it.
Okay, so this thing's on a timer. I'm just going to let this thing time out before I stick my arm over it. I've been a good ground before. I don't want to be a good ground today. Yeah,
there's nothing like getting hit by secondary, right? All right.
But you can see this thing's a pretty good pattern here. So when we talk about our string theory, we're talking about every coil has a certain amount of energy from the duration that it's charged, and we call that maybe. Oh, where's my? Let's see what we got here. I think I'm drawing in the same color as a board, which isn't always good. So every coil puts out amount of energy, and we can call that maybe our string. Now, if you look at our string, whatever we use for our burn time is going to be affected, or for our firing kV is going to be affected in our burn time, right? So when we had that large gap, we used so much of it for the kV that we didn't have much burn time. And when we had the small gap, we had less kV, but then we had more burn time. And this is kind of exactly what's going to happen in the cylinder when you change your spark plug gap. You're going to affect the kV, which is going to affect the burn time. And then we talked before about what's better. And it really, it really means like, a big gap can be better, but you may overstress the coil.
Possibly.
A small gap could be good, but then you may not have enough KV.
You could end up with incomplete combustion.
Mm-hmm.
I mean, really what this is showing here is depending upon the coil and its construction, the windings, its output or available energy, and then also depending on the time that the coil is actually turned on, you're given a piece of rope that's only so long, and either you're going to use a lot of that rope to jump the gap and then only have a small amount to actually burn inside of the cylinder, or you're going to use only a small amount of that rope to jump the gap, and then you'll have a really long burn time.
Exactly.
I mean, ideally, you want the burn time to be as high as possible, or as long as possible.
Without overextending your length.
Right, without stressing the coil too.
So it's safe to say you need to find somewhere in the middle, and I guess every engine's going to be different too. Whatever your stress is going to be, and we're only stressing gap here. Obviously, there's so many more variables in a real engine, right?
For sure.
Pressure inside, or fuel.
Yep.
Turbulence and things like that we don't have affected here too. So
exactly. So I think we can say that spark plug gap is it does matter.
Yeah, I mean it matters. I mean it significantly matters, and we were just changing the gap 20 thousandths of an inch.
And it's hard to say what is the right gap. I would say for an OE application, a direct replacement application, follow the manufacturer spec, whatever it is in the owner's manual or that that sticker under the hood. I guess engineers were kind of right on spark plug gap, right? They spend a lot of time and effort designing that gap. They might as well follow that.
And we got some really good questions on here, and we're actually going to get to some of these, which I'm really excited about because I'm glad that you guys are thinking. The wheels are turning on these questions here. So this one is confirmed.
Awesome.
So now that we know that spark plug gap matters, what's our next question here?
Let's get to the next one. Box number 2.
Box number 2. I also have that down here. Oh, this one's pretty heavy, Mike.
A lot of stuff in there.
Yeah, what is number 2? I don't remember.
Number 2, worn out spark plugs kill coils.
Ooh, that's a bold statement.
I mean, I've said this in the past, right? I mean, we've seen coils get killed. We've seen coils actually melt like this one right here. But what is causing it? Are worn out plugs causing it?
You got it.
And what is worn out? What does that mean? What is worn out?
I mean, I would say past the maintenance interval, right?
Worn out doesn't necessarily mean misfiring, right? Worn out would be beyond its service life, right?
Define the service limit, yeah. And then when we talk about kill coils, let's be specific. So or not specific. Let's just talk about what actually kills a coil, right? What actually kills ignition coils?
Well, coils go open or they short.
Well, we have damage, and we're not going to say damage. I mean, you can have damage, and we're not going to consider that a spark. But what would a spark plug? So I've always thought that what kills ignition coils is heat. Heat is what kills ignition coils.
Yeah, that sounds about right.
I mean, and if I'm thinking if a spark plug is going to kill a coil, it's going to have to do with causing it to overheat.
Well, an excessive gap, high gap.
We know that the gap causes,
KV.
and then a worn plug. So. But is it going to be noticeable enough to hurt a coil? I don't know. So we can test this.
When we're talking worn spark plugs in the past, when we have the copper plugs, nickel plugs, whatever the case, what's going on?
We've got some smart people in here. I love it.
Awesome. When we're talking worn plugs, in the past those plugs would actually physically wear, right? We would see them with massive
You
gaps.
had those old copper plugs you'd pull out, and you could drive a truck through them. They were so big.
Yeah. I mean, that's the brand new plug, and that's a plug. Oh, yeah. That one is significantly
That one's on Mike's car.
It's in. It is not. But that one came to us for a no-start issue, actually. But a significant wear there. But you don't see as large of a gap or as significant of a wear on these newer precious metal like iridium plugs. You see a little bit of let me give you guys a close-up of that. A little bit of like a ground electrode wear on there, right? A little angling on there. But you don't see it as much to the naked eye. But where you do see it is under a microscope. If you look at 150 times zoom, see we got nice, sharp, beautiful edges on that center electrode there, whether it's platinum or iridium. At 30,000 miles on that spark plug, you can see it rounding over and getting worn. So when we're talking worn, we're going to define it as a spark plug that has made it to or exceeded its service interval.
It's service interval, exactly.
So that's kind of what we've got here today.
And these are some pretty good pictures. I mean, you can see some pitting on this 80,000 mile one, and you can even see like it's starting to round off really bad on that one edge.
Yeah. So even though we're not noticing massive gap degradation, we are noticing wear to the spark plug. So let's do some side-by-side testing on these. We've got 4 brand new coils that have not been run yet. And then
what we also have is we have 2 kinds of plugs. Now we have the brand new version of the plug, and then we have the old version of plug, and these were actually out of cars too. This isn't something that we mess around with. This one's out of a Ford
So that's
truck,
an EcoBoost
like.
plug, actually.
Okay.
That's out of my truck at the maintenance interval.
Oh, so we do got one of Mike's spark plugs, so that one should be pretty bad.
We'll see. There was no misfire complaint, but this spark plug was at its maintenance interval.
This looks like a V-Power.
That's going to be this plug right here. This was actually the one that we had in this picture right here.
So I say we start with the normal copper type plugs ones too, because it definitely looks like it's the worst one.
Right. So we're going to put them into this test bench fixture here.
I'll open up the coils.
Okay. And we'll put them kind of close together, and then we'll make some measurements here, lay out our test procedure. So, oh nice, the gaps are sticking towards the front there, that's nice.
And we're going to use these extenders on here so we can get a secondary ignition pattern easily on here. This is why this is going on here.
So we've got old and new. I mean, let's measure the firing KV and the burn time.
Okay, what do we got here?
And you talked about heat, right?
Yeah, so heat's what I think kills coils. So I'm assuming that the one with the worn coil should heat or the worn plug should heat the coil up a little more than the other one.
So we do.
If we can fire it long enough, we'll see.
We do have a thermal imager here today. So can you point that at the...
oh, how convenient.
Hello. Oh, hi guys.
All right, let's see if we can get that right at the table
go.
here.
So we'll be able to we're going to be able to actually track the temperature, and I think, yep, the thermal imager right now is set on hot spotting, so it's going to pick up whichever coil is hotter when we run this. So we're going to be able to look at firing KV, burn time, and temperature as both of these coils are firing these 2 spark plugs. Again, the brand new version of the plug and the plug that's made it to or exceeded its service interval.
All right, so we need to get this off of here.
And because we're firing 2 spark plugs simultaneously, unfortunately we don't have the ability to run them under pressure. So our KV numbers will be lower on here because we're not running the pressure. So we got 2 probes. I'm going to get the scope set up for a second probe. Oops.
Hopefully we have these on here right. We'll have to invert them.
Scope is set.
And if you're wondering, we have a lot of redundant grounds around here to protect ourselves.
Okay, both of those are set.
Let me just make sure I have these wired correctly and I'm not firing one of these backwards. Blue is power. The thing I love about the coils we're using is they have battery positive marks on them. Okay, so we should be ready to go.
I buy all my yoga pants from Glenn exclusively. That's oh boy. I definitely am not a yoga pants wearer. Let's see what the thermal imager, let's get that set to.
Let's get this looking at the base. Ooh, a little bit too far there.
Okay.
Okay, so we have.
Can we get them so that little red, this little red piece in the middle here, if we get them close enough together, it should be able to pick up. We want it inside of that square. There we go.
Does that look good?
Yeah, that looks good enough. Okay, so let's give you guys a close-up shot of what we got. Oh, let's try this one. So this is what we're dealing with here. Thermal imager over to the side there, and we're going to fire both of these plugs.
And we're going to use this thing here.
All right, fire it up once. Let's see what happens.
All right, let's see what we got. All right, they're firing. They're going.
Alive.
They're going.
You can see on the scope it's doing something.
They look pretty. I mean, the patterns look pretty close actually for a worn and a non-worn plug, which is interesting.
We got. Oh, camera's calibrating. So no significant changes in them yet, and I don't know if we're going to see one coil getting warmer than the other. We're assuming one is working harder than the other. Let's take a look at the lab scope here.
They look pretty close in burn time, and I'm assuming the KV looks close.
All right, so which one is which here?
So the red channel is the new plug, and the blue channel is the old plug.
So our new plug, peak KV, we'll call it about 7. And the worn plug.
And this worn plug wasn't taken out for a misfire. This was actually just a replacement plug. So it you know, maybe it's still within a decent spec.
9.6. So 2,000 volt difference.
So the worn plug is actually firing a higher kV, huh?
Yep.
Okay.
So which we expected to see, right? We already proved that a larger gap affects the overall output kV. Now, what does our actual burn time measurement look like here? Look at that. So our burn time is shorter on the blue trace, which is the worn plug. Our burn time is longer on the red trace, which is the new plug. So, I mean, that kind of proves our string theory right there, right? That if you take more of the energy to jump the gap, you have less of the energy for your burn time.
So, I mean, it's definitely making the coil work a little harder. I'm not sure if we're running them hard enough on this test, but how's our heat look, Mike?
They look pretty similar right now. Touch both and see which one hurts more. I mean, if anybody wants to head to Fond du Lac, Wisconsin and see which one hurts more, you're more than welcome to.
I did before. They both hurt equally. So not a significant difference. I
mean, kind of unexciting. It's kind of not as fun as I was hoping it would be. Which one? Interesting. Oh, that is the worn one. So my finger here. Burr, 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 burr.
He's touching it.
Trying not to. This right here, this is the worn spark plug coil at 83-ish degrees. So that is the hot spot. Let's. They're both like the same. Crazy. Now I wonder what would happen as we run this thing for a long time, if we were to run these in pressure.
And I'm wondering what would happen, you know, if we took I mean, this is a used plug, but it's not a plug that we've confirmed that causes a misfire or is so far out of spec that maybe would cause more of an issue. We wanted to kind of keep it a real test that we could have just, I mean, I bet if we jam that thing open and really raise that kV, it might change.
Well, and if we had cylinder pressure, I think that would have an effect on it as well.
Yeah.
So kind of uneventful on temperature, but we definitely know, you can go ahead and turn it off.
Yeah.
We definitely know that the worn plug, the plug that's made it to its service interval, in this case, in an old school plug, is affecting the output kV and the overall burn time. Let's swap them out now.
So let's swap them out, and we're going to use different coils just because we don't want to wait for these to cool off.
All right.
Okay, we got this one out of here.
So now we're going to run we'll keep it consistent. We'll run the original, call it the worn plug on this side.
And these are iridium plugs, or what kind of plugs are these?
This one, yes, this is an iridium plug. Oh! Should hire an assistant.
I wish all coils were this easy to get to when you're scoping them.
Uh-oh.
I don't like uh-oh. At least it's not on when you said that, so that's good. Okay.
What do we got here? We got something. Oh, we haven't taken the plug out of the box yet. That's why. I was like, the nut doesn't fit on the plug. Something's not right.
He says I was on coil duty.
It helps if we use the right spark plug. If I use the right spark plug, sorry, I'll stop saying we. I just keep cross-threading it. Cross threads are better than no threads. Seriously. This is painful.
A little painful. I'm having a good time watching him do this, so.
Do you guys remember that time I was taking a wheel bearing out live on camera?
Put that in my video list to watch.
That was even more painful. I think this nut is something wrong with
Here.
it. It is. Somebody smashed it.
Try that one.
Jeez.
We got extras.
Hey, there we go.
We got extras. I think someone used an impact when he wasn't supposed to use an impact is what I think happened to it. Oh, sorry.
All right, so we'll set them next to each
Hold
other.
on, now I hook it up wrong and make it even more funny. So
We got power in the right spot?
Oh yeah.
Okay, resetting the scope, trying to. Scope's reset. Let's get these guys close together so we can watch on the, all right, that works.
That works.
Okay,
All right.
fire in the hole.
You ready?
Go for it.
And ooh,
Action. Ooh, that's some like,
little noise there.
whoa, that's kind of cool. Here, take a close look at that.
So we got a little bit of noise there. And that is the
That's the worn plug.
that's
so
the warm plug too.
interesting. All right, let's take a couple quick measurements. It looks like our new plug is running, averaging 8.5-ish. And our worn plug is averaging, I mean, that's pretty much the same. And our on time, or our burn.
So we see we got some questions, or not questions, but statement is if the amperage is not different between the coils. And that definitely is true, but what we're testing is we're making sure we have the same coil with the same on time, and we're hoping that the amperage is the same. We're just seeing if the plug itself would cause the coil to be damaged. If with the same on time and all the same parameters, if we had different amperages between these coils, the test between the spark plugs would definitely not be good information. So, but definitely, if you had different amperages between the coils, then there would be something wrong either with the control or the coil itself before the test was even started, probably.
Let's measure the amperage quick.
Yeah, and we can measure that.
This clamp, excuse me, I might be dying here, but this clamp doesn't even have battery in it.
Well, let's see what else we got over
Somebody
here.
robbed the 9-volt.
Lucky I always come prepared here.
Well, one of us had to. Let's throw that on, can you throw that on channel 3? We'll grab, you can go 20 amp.
Let's turn this off and bring it back on, or do you want
Leave it
leave it run?
run, because I want to.
We got plenty of coils, right?
See what those thermals are doing
All right.
while we're waiting here. So,
Is it zeroed?
yeah, looks like it. So
Okay.
80 degrees, 82 degrees. So we're actually seeing a little bit of a temperature difference in these two.
Okay, let's see what we got. I mean,
All right, amperage. Let's see, we are off the screen. Okay, so we're currently on which one?
we are on the red chase.
Red trace. So the new coil is currently pulling,
New spark plug coil. They're all new
sorry,
coils.
new plug is currently pulling, let's grab the right thing here.
You'll get it.
7.5 amps.
Okay.
It's kind of a lot.
It's a little 2-wire.
Jump on the other one. About the same.
Yeah, so this is exactly what we wanted, though. We wanted them to draw the same amount of current with the same on time, same coil, same everything, to see if the plug itself would cause the kV to go higher, to possibly overheat the coil. And maybe a little bit, maybe our plugs aren't worn enough. We could have maybe, threw a huge gap in there or something to heat them up.
But this is real world. I mean, that plug came out of my truck at its maintenance interval. So, I mean, that is real world. Now, look at, I find this interesting here, if this will work. Look at the scope. The worn plug, even though it's got all that noise and that weird hash in there and everything, the worn plug is actually showing a slightly longer burn time.
Which is interesting.
Can you get a close-up on that? It's really interesting that the spark is a lot more mobile. It's dancing around a lot more on that worn plug.
Let's see if I can.
All right, take a look at that. So it's kind of hard to tell. Yeah, it's kind of hard to see for you guys there, but the spark is a lot more inconsistent on this worn plug than it is on the good plug. The good plug looks like it's firing over and over and over again in the same spot. This one's a lot more inconsistent. Interesting. KV reading, again, blue trace was about 8.7. So the worn 8.7 and the new 8.3-ish. So
I think it's safe to say maybe our test here is a little inconclusive, but we were thinking, what would we do if we put a huge gap in there and really stress this coil out? And that's exactly what we did do.
Well, let's check temperature real quick here.
Well, these ones are pretty close. Well, yeah, I guess
95, or put the square center of the box right over the hot spot. So peak on that coil is 94.
Ooh, going backwards here.
So about the same.
Yeah, they're about the same.
Okay, interesting.
So not a huge effect on this, but
you can go ahead and shut it off. So I guess the temperature was about the same, right? Oops.
Yeah, I would say temperature is very close on these.
I have too many mouses over here. Oh, and there's caps lock. Oh, jeez. Oh, jeez.
Burn time was pretty close. I mean, almost immeasurable on these plugs. But like I said, these plugs weren't failed plugs or very, very worn plugs that cause any issues. They're just set of used plugs.
Kind of did a bad job recording on this one, but we saw with the nickel plug, the original plug, the ones that came out of a Chrysler, we saw them at just like we'd expect to see, larger
Slightly
gap,
higher
KV, lower burn time. Now, in dramatic fashion, of course, we ran this test when we were working on some setup here with some different coils, and we let them run for a really long time to really get them stressed out. And here's what we had found running two different coils. Same thing, except we ran one plug with a standard gap, the OE gap, and then we ran one plug with an extended, much larger gap.
So something that would possibly cause a very high stress or maybe even a misfire in a car.
Yeah, so we saw, that higher KV to jump the gap, that lower burn time, and we saw almost a 50-degree difference here in running temperature. And actually, we saw a physical difference in the coils themselves. You want to grab those off the bench there?
Yeah, let's take a peek.
It's kind of cool to show.
And let's actually get the point shoot so they can see exactly what we're talking about. So these are the coils that we ran on this test before. And if you look here, you can see how that's almost discolored. This is the one that got hot. It actually discolored the top of the coil and started changing the look of the logo on this thing.
So it actually discolored it.
And I mean, we really stressed this thing out, though. We brought this thing to its limits. And at the end of the test, even when we put the gap back, it started shooting a little bit different of a secondary ignition pattern. It started looking a little funny. So maybe...
Should we show those? Do you guys want to see those coils running quick? I mean, we could... They're just
let's see. I mean, they're cool now, so I'm not sure if they're still going to do it, but let's see if they still show the different pattern just from stressing that thing out so bad.
Did the primary resistance measure the same on those? I don't remember.
It did before we did the test. Let's see if it changed at all after we...
It's one thing we haven't really talked about here at all yet is any primary resistance of the coils. Because we've been using the same coils over and over, now we do have a potential for a difference in primary measurement because we had gotten one coil excessively hot.
Now this one's about 0.7, and I could even put this out here for you guys to see this here.
Like trying to look over there.
Yeah, right. The first one was 0.7. Let's see what this one is here. And when you guys are talking about coil amperage before, this is exactly what's going to reflect how much amperage these coils draw, is what their primary resistance is. And it looks like this is 0.72, but I'm looking from pretty far away. Is this 0.7, Mike?
Yeah, 0.7, 0.8.
So it looks like the primary resistance didn't change from really beating these things up.
All right, well let's, these guys are warm. Let's fire them once and just see if, because I think I kind of remember them shorting out a little bit. I don't know, we'll see what happens here. Ground is yellow, right?
Yes. Ooh. Ignition modules are getting a little warm too. We got a little heat sink here, and you can actually feel this huge heat sink starting to warm up a little bit, which is pretty cool.
Okay, back on the scope, resetting, should be good.
You ready?
Should be good.
The first time we did this test too, when we really stretched these out, they were the same kind of plug. They were a bigger gap and smaller gap, but they were the same kind of plug, so it might be a little different too. But yeah, look at that.
So the blue coil, which is this guy right here, is our discolored. Let me show you. That is our discolored coil. And you can see here.
Yeah, the leads are from ASE Test Wave.
ASE.
We got some
AES Wave.
Waste Spark presentation.
Waste Spark. Waste Spark. You talking about Waste Spark? Not today, Keith. We'll save that one for another day. Yes, that's the AES Wave kit. It's phenomenal, of course. Okay, so interesting to see the difference in there.
Someone's asking an app clamp. We can throw that on there quick.
Let's do it. Okay. Which one are you doing first?
Turn the channel on.
It is.
Okay. So this is going to be the red trays.
So the good one.
And with the resistance measurement, I would assume that they would do around the same.
7.6-ish.
It's amazing what these little how much amperage these little 2-wire coils draw, isn't it?
With a 2 millisecond on time,
yeah.
Which is maybe a little high.
It's a little high.
A little bit less amperage on this one, 7.4.
So a little arc to it.
A little less of an amperage. Actually, let's put that back on there quick on the one that got hot. I just want to see the initial on of the coil. This guy right here.
This is a hot one?
Yeah.
Okay.
Just want to see the turn on. So really, what we're looking at here is this initial turn on of the coil. Just kind of tracing this up to see if the magnetic field is building in a steady cadence or if it's a quick jump in current due to like shorted windings or something like that. But it looks pretty good. Can we jump over the other one just for comparison?
There we go.
So a little bit different looking on that initial ramp up.
And these are the same part numbers, but everything else is the same too.
Well, the part numbers are actually different. I've said in the past that these were the same part numbers when we did testing with these coils.
Well,
but actually,
now he's lying.
They're 1 digit off, but the only difference is the coil boots themselves. Okay.
Take his word for it.
So we can shut that off, I think. All right.
Computer went to sleep here.
Just making sure we're not missing anything here. Question, what are you guys going to do the waste spark? Oh, Keith's rolling his eyes because we're not covering waste spark today. Okay, back to the task at hand. Killing coils, right?
So our test that we did here, really, I don't think we stressed the coil enough. And our time basis is a trip to the mini mart, maybe, not a trip to Florida. So maybe there'd be something different. Plus, there's a lot of variables that we don't have here. But when we did this test, the other one that you showed before, where that one was actually 50 degrees hotter, I think it proved that under extreme circumstances, there's a really good chance that if you had a bad plug that was like really fouled or really worn, you definitely could create some extra heat. And I think you could really hurt a coil with something bad. I mean, any high secondary is going to put stress on the coil. So,
yeah, any changes to the gap increases the KV, increases overall
yeah, I mean,
temperature.
our test is plausible. But my gut says that would be a confirmed that it could happen.
So do we kind of put that one in the middle there? What do you guys think? Confirmed, plausible, or confirmable?
Put it right in the middle is good, right?
Yeah, mashup. And really, spark plug maintenance intervals are there for a reason. Okay, 2 down, 4 to go. I think we're an hour in.
2 down, huh?
That's 2.
All
okay,
right.
Before we get to the next one, our third on the list, I think it's time to give away another T-shirt.
Yeah, I think so too. They seem to like T-shirt giveaways. Everyone loves a T-shirt giveaway.
Yes, combustion. I would say yes. In other words, heat, vibration, high kV, and excessive resistance destroys coils. I would agree with that.
Yeah, I think so too.
Okay, so we're gonna do an easy one here. Currently, we got 132 people on at this moment.
Okay.
I'm thinking of a number. We're gonna make this easy just because I want to give something away. I'm thinking of a number between 1 and, what the heck? It just updated to 181.
Someone heard free t-shirts, and then they all came.
Thinking of a number between 1 and 181. And I'm gonna write it down.
Hello from France.
Can
Hello.
you see that? That's my number?
Okay.
All right, in the chat.
I'm gonna write it on my notepad too in case he tries to change it.
I'll put the pen down. Number between 1 and 181. Nobody's gotten it yet. People are close. Tell me if you see it. I haven't seen it yet. Oh, that was close.
Oh. You can guess more than once?
Oh, you can guess as many times as you want.
Keep guessing.
Oh, come on. Somebody's got to get it. All right, it's over 100.
Oh. Oh, there is so close.
It's under 150. Oh, I'm losing track.
I can't even keep track. It's going so quick.
Oh, there it is.
There it is. Matt.
Eberl? I'm sorry if I'm massacring your last name. Matt, you are the winner.
132.
With, 132. Beautiful.
I can't believe you guys can type numbers that fast. That's awesome.
Email. I would say scroll up for the email, but that might take a bit, so we'll just go here.
And remember, make sure that you put your size and if you want pocket or no pocket for the t-shirt.
I think I spelt all that right. Send me out an email. Matt, congratulations. You are a proud new owner of a GoTech t-shirt.
We have somebody said they put 132 before that. We'll go through them.
Man.
We'll go through there and check.
You want to...
And we can just give away 2 shirts if he was there before then.
So we're gonna do 2.
We'll go through and check, and if you were there before, we'll give away 2 shirts.
The chat was rolling in so fast.
It was coming in real quick. So make sure that you also email us.
Oh man.
All right.
We'll have to go back in there and Kevin put 1,232.
I did see that.
Boy, I don't know. I'm looking at the chat here, and I'm only seeing 132 come up by Matt. But we'll dig back through there and confirm. So,
okay,
worn out plugs, killing coils. We're gonna say in the middle between confirmed and plausible. We didn't really have a way to, unfortunately, really show them a massive difference between the two. Okay, let's go on to the next one.
On to the next one.
Plug type doesn't matter. If it fits, it ships.
I almost lost number 3. Okay, so we have number 3 right here.
So, the theory behind this one is you walk into a parts store, any parts store, you log into, you go on to any sort of online retailer store, and you're going to see plug types and plugs, multiple for the vehicle. What do we got in there?
So what we have in here is a bunch of spark plugs.
Sweet. So let's take an example vehicle here, because you get a lot of different plug choices. This is a 14 Tacoma, and to be honest with you, we only picked the vehicle because it's what was in stock here when we were getting our plugs. But there's 23 different plug choices listed on an online retailer's website for spark plugs. 23 different choices. And here at a local parts store, you can see 5 different choices here, ranging from a little over $7.50 a plug all the way up over $15 a plug.
That's a lot of choices.
You walk into a Toyota dealer to buy a spark plug for your 2000 and what did I say it was? 2014 Tacoma, and how many options do you get there?
I would hope you'd only have one option, right?
I don't know that there's really. There is examples out there where the dealer may list 2 different spark plugs, maybe, but majority of the time, the dealership's going to have one spark plug for the vehicle.
When we're thinking about different spark plugs, what are we talking about here, Mike?
Well, obviously...
We're not just talking about brand, right?
Not just brand, no. We're talking about...
obviously brands are probably different, too.
The design and the material used in the spark plug. So, a little bit of history. We've all seen this type of spark plug and that type of spark plug and most of these, but have we all seen the PSPE design with the little platinum chip sticking out of the end? There's a reason why so much time, money, and energy was invested into designing these different plug types and these different materials. Does it matter? what does it do for us? What is it for?
And if it does matter, does it affect what we're testing today? Does these, I mean, obviously they've made different spark plugs for some reason or another, but how does it affect the actual ignition system? Is it,
well, and then we get plugs
is
like
it
this guy.
affecting the KV of a spark plug? Is it affecting the burn time of a spark plug and without condition changes?
We can definitely measure that. Let's measure that, but let's first look at this plug. Can you give
what is that
give
thing?
them a close up?
Let's see here.
Maybe down on the table.
Yeah, let's see what we can
So
get.
this is a factory plug. Have it pointed down more. The whole camera. There you go.
Okay, there we go.
There we go. So this is a factory plug out of a Lexus, like the Lexus 3.5 and like an IS or RS 350. And you can see it's the triple ground. That's an OEM design in that plug. So what happens if you put a plug in there that's not that design? And just for factual purposes, that plug is designed that way to reduce the ability for that spark plug to foul. If it were to foul one of the ground paths or the path to one of the ground electrodes, it would allow one of the other electrode paths to take over and get that spark plug back up to operating temperature to clean the carbon off of it. So factory design on that. So without even doing any testing, my gut's already saying, my hypothesis on this experiment is saying that it definitely matters.
Well, obviously we don't have time to test 30 different or whatever different spark plugs are up there. So what do we have? We picked a OE plug.
So we'll put that one in the middle. So we have the OE plug, direct replacement, exact replacement.
And then we have the basic plug, I would call it, or maybe the value plug, maybe we call it?
Sure. So we'll call that, well, that's a V-power plug, so we'll just put V-power.
Okay. And then what do we have here?
The ruthenium plug, which is, in this case, is going to be an upgraded design.
This is not, okay, so this is not, and then the OE plug is a iridium.
U-T-H-E-N-I-U-M, ruthenium.
I can't even say it, I don't know how to spell
so
it, that's for sure.
I guess the biggest thing here is this OEM plug, the direct replacement plug, is a fine wire center electrode and a traditional ground electrode.
Okay.
The ruthenium plug, so it's going to look like that one in the upper right corner. The ruthenium plug here is going to be the upgraded design with the DFE or the dual fine electrode.
And this is the new technology, huh?
Which is going to be like this guy right here. So does that make a difference? We can measure the KV and burn time for sure. So why don't we?
And I think let's use this one for it so we can put some pressure under it too, since we're just doing one at a time here. So we're going to start with what? You want to start with OE?
Yeah, I'm going backwards here on the slideshow. Let's go to the right spot. Okay. So we'll do firing KV, and we'll do burn time again.
OE. Okay, so let's get this thing hooked up and see what we got here.
You got the other two over by you?
Yeah. We have the this is the special plug. We'll get that out of the way. So we don't
man, this is a different size.
Not all spark plugs have the same thread size, so we have to have a few different options here. Okay, this is the. Okay.
All right.
Let's see what we got here. We got here. Okay.
So for baseline purposes, the OE plug is going in.
And let's get our testing equipment hooked up here first. Also.
And we'll just run. You know what, we'll keep that amperage channel on. Scope's good, pressurizing now.
All right, this should be on the blue channel.
Okay, fire in the hole.
Interesting. It's amazing how much resistance that chamber creates. You can see, I mean, it's a pretty ugly looking pattern just from having pressure and no fuel in there.
All right, so we can achieve a baseline here. Say our KV on average-ish.
It is interesting as the pattern looks. The spark inside the cylinder looks pretty normal, actually.
Can you fire that off again? I didn't.
Sure can.
I should have saved the capture. I was trying to grab an average on KV output. 27-ish, I would say. Let's call it a 27K. KV average. Our burn time's all over the place when the spark gets kind of weird there. Let me show you guys. When this gets kind of weird, our burn time is dramatically affected. Let me pause it. There we go. So we'll call it 27 kV with a 1.06 millisecond burn. So our OE plug 27 kV 1.0. Oops. I think I said 1.03, right?
Yep.
Okay.
So go down next. V-power.
Sure. Try not to get all these mixed up.
Oop.
Cross threads are better than no threads. Here.
There we go. All right. Now, most important thing. The most important thing.
Wire. It's all fun and games until somebody forgets to put the secondary wire on. Okay, resetting the scope. Here we go. So this is the V power plug.
It's pretty much.
So our measurement's exactly where it was before. Similar kV.
But and there's a lot of factors that aren't inside the plug hole, but I mean electronically I would say, or kV to burn time, they're pretty comparable.
Yeah, I'll call that 27 kV, and our burn time is about the same.
Well, that lean condition is really causing some stuff in there.
Oops. Okay, so we'll go 27K, and we'll go with that 1.03 again.
And that was the V-power, right?
That was the V power. Man, I can't type today. Try that again.
Oh, it's off. I thought you were gonna hit the button. Shouldn't have said anything.
Next.
All right, so this is the.
So this is the DFE design, the dual fine electrode.
Dual fine electrode. Okay, we're grounded. Back to pressure.
Are we good to go?
Let's go to our scope here.
Maybe. There we go.
Interesting.
A lower overall kV.
I was not expecting this. Now that we got two in a row, I was expecting them to be the same.
Let's call that a.
It's actually lower with a little more burn time, I would say.
I mean, if we're just trying to shoot for averages here.
That is interesting.
Huh. About a 1.3 millisecond burn time with our kV averaging lower around the 24. Okay.
Yeah, I didn't see that one coming.
4,000 with about a 1.3 millisecond, which makes sense, right? Our overall need for kV went down.
Yeah, just
so
like
our burn time went up.
Yeah, longer burn time, lower kV.
Exactly.
Yeah, exactly. I was not expecting the new plug to do that. I wonder, I really don't know the reasoning for that, but I mean, everyone could be different too. We're testing only one plug.
True.
Or one kind of, or one type of plug for one car.
So, I mean, looking at the technology and its effect on the secondaries output, kV and burn time, the technology has a slight variance on overall output. Would you agree?
And I say that too. And so I guess the real question would be,
well, we're missing a major factor.
We're missing the major factors, but I guess the real question is that we're trying to answer is, does the plug type matter? So electronically, they're all going to be pretty close, but
what we're missing here is the flame front, the flame kernel inside of the cylinder, the explosion that happens, and that is actually what the main driver is behind the changes to spark plug technology. So I got some slides here that kind of show this stuff because we're not able to actually see it, but let me show you guys what I'm talking about here. So up close and personal with a couple spark plugs, you can see an iridium fine wire plug is a really consistent spark in one spot. And you can see like the V power plug, it's kind of dancing all over the place, right? We got spark kind of inconsistent, happening kind of all over the place. But it's still creating spark. It's still
and spark's still going to ignite
explosion.
Fuel, but there's got to be. I mean, they would if they perfected the spark plug, they'd stop making new designs, right? I mean, there's got to be something that helps.
So if we look at this, according to where I found this this chart here, the electric field's intensity is actually stronger when it's more consistent with that fine wire iridium plug versus a more spread out, weaker intensity field. So
and then you're saying since stronger is going to be more heat, right? I mean,
more heat, so we should, in theory, get a more efficient boom inside of the cylinder. But we can also look at this. So I'm not sure how these images were captured, but they're pretty amazing to think about. So you have three different plug designs here. You have the newest design in the what's called PSPE with that little platinum chip sticking out the end. You have a traditional style fine wire, and then you have a very traditional large center electrode plug. And this is this bubble that we're seeing is actually it's the explosion or the flame front inside of the cylinder expanding outwards after the ignition event. So from the ignition event to 3 milliseconds, we're seeing a difference in the expansion of that flame front, which leads to different combustion pressures ultimately because of timing of the piston.
If the explosion happens faster, it can happen in a smaller area if the piston's closer to top dead center, which makes maybe more force would be applied.
True.
Also,
so
I mean, what are we advancing cars for anyway, right? So we can that flame front can get a head start to get complete combustion. So maybe it could help there a little bit.
So really, the technological advancements look like it's a reduction in what's called quenching, or the spark plug's ability to block or absorb the flame front. We're trying to keep the spark plug out of the way of the explosion as much as possible.
That's a really cool picture.
So what it ultimately, according to the graph here, what it ultimately does is it creates a more consistent cylinder pressure, because if the flame front, like you said, with timing of the piston, if we fire the spark plug before top dead center, the flame front starts, it explodes out, it expands. As that's expanding, we're starting to put pressure on the piston heading downwards. If the piston is higher in the cylinder, when our explosion is bigger, our pressure should be a little bit higher.
Because it's going to be a smaller area, right? It's like the difference between lighting a firecracker in a large room or lighting a firecracker in the palm of your hand with your fist closed. It means you're going to create more pressure in a smaller area.
One hurts your hand, one hurts your ears.
Yeah, exactly.
Well, and really, I don't know if a 37% improvement seems a little, call it dramatic here, but according to this test here,
that seems a little high.
If the plug was fired at 20 degrees before top dead center, so piston is still traveling up, spark plug fires at 20 before top dead center. Our air-fuel ratio on this vehicle apparently was a little bit rich at 14.5 to 1.
That's interesting too, the 14.5.
We're able to apparently achieve a higher cylinder pressure.
An overall higher cylinder pressure.
Because of the placement of the piston. So the combustion speed, the event of the combustion is faster, and its relationship to the piston actually creates a higher cylinder pressure.
And obviously everything's going to be different. Every motor is different. The airflow in every motor is different. The compression ratio in every motor is different too.
Glenn's comment there.
Yeah. But I guess, I mean, this just proves that there definitely is a difference in technology. Yeah. So getting back to our real question, does it matter? I mean, so
there's one other thing we haven't even talked about yet. Maintenance interval. Right, the most obvious of things.
Yeah, right.
A fine wire spark plug with an iridium or platinum tip on it versus a nickel spark plug with that wide tip have vastly different maintenance intervals.
I mean, as time's gone by, maintenance intervals have been going up.
They've changed. The theory of iridium plug gets 100,000 miles isn't necessarily true. I mean,
it seems like now plug intervals are going back down, and that's really interesting to me too.
Well, when you have race cars like a 13 Dodge Dart with a 1.4 turbo, you're running like a $20 spark plug in that engine. That's only getting 30,000 miles.
And
so
this is interesting to me too. I mean, now we're talking about these laser iridiums, but they're supposed to be 100,000 mile plugs. Why would
that was the theory.
Why would it be a 30,000 mile interval? And it's pretty much everything we're talking about today, right? It's resistance and pressure, or the kind of environment they're in the cylinder. If you notice, this thing's turbocharged and it's probably running really high compression. Lean as possible. I mean, so even though the spark plugs have gotten better, they started running engines under worse conditions that are bringing the maintenance intervals back down.
We got the classic 2.4 liter in the Jeep Compass that runs a 30,000 mile nickel plug. So in that case, if you were to put an iridium plug in or something like that, you'd get a longer maintenance interval, a slightly different output kV, and potentially a more complete burn.
Depending on the motor, you might get a little bit better burn. Yeah.
So does plug type matter?
I would say it does. So then, I mean, it has to matter, right? So are we always? But I guess what we haven't talked about either. So we've been talking a lot about upgrading your plug, right? So if we go from an upgraded, we're going to get better flame front possibly, or we're going to get longer maintenance interval. What we haven't talked about is what we really probably downgrading. I mean, that's where you really probably would run into the most issues, right?
The engine is designed for a specific plug firing end type, and if you go backwards,
we can talk about waste spark. We can talk about waste spark.
Here we go, Keith.
Here we go. Let's talk about waste spark. So in a waste spark system, it fires two plugs at the same time. One plug fires from the electrode to the tip. One goes from the tip to the electrode. So that's something where it could really mess with putting the wrong spark plug type in, right? If you only had precious metal on one side. I think you were telling me before that the older waste sparks had two different.
So before there were like dual precious metal plugs, there was two different part numbers. You would end up with a spark plug that had precious metal on the ground and a spark plug that would have precious metal on the center electrode, and it would just be used to combat wear at that point.
Or you did the spark plug rotation, right?
Spark plug rotation?
You just sold the spark plug rotation with the tire rotation.
The spark plug rotation, where you swap plugs side to side so you get even wear.
Or you just take the wires and right?
You know, waste spark was fun. It was fun to work on. Do I miss it? I like working on coil unplugged cars.
So I guess it's confirmed, right?
Well, the question is plug type doesn't matter. So I would say that.
Oh, it doesn't matter, yeah. So it's busted. It definitely does matter.
It definitely does.
So
maintenance interval.
So I think
design.
So moving up may give you some performance benefits. Moving down may be a really bad idea. Personally, I'll probably just stick to whatever the car says.
Yeah, what came out is what goes in.
You know what I mean? Maybe move up a little bit, but I guess I would say, yeah, that's busted. This definitely does matter.
I agree. Does everybody else agree?
And I've seen a lot of, looking at the comments here too, I love a lot of people saying like, well, this brand had a problem with this car, or this car was very finicky. And that's another variable that we haven't talked about is every engine is going to be different. You know, I remember some cars wouldn't run right on this type of plug or this brand of plug, and then they would run really good off of this type of plug. And it's kind of that trial and error, right? You can do the trial and error to find the best plug for your car, or just use what the factory says. But hey, the factory's not always right either. They have their own issues sometimes.
I mean, they do, yeah. But in this case, the engineers are traditionally pretty.
It's not saying that putting this 3-electrode plug in your car is going to give you any performance boost.
Yeah,
or anything like that.
in a vehicle that requires this plug, it makes perfect sense. But if you were to put this into a vehicle that doesn't require it, and now you got all these ground electrodes blocking the flame front, you're slowing down combustion speed.
Exactly.
So there's definitely a dramatic negative effect to quenching in the cylinder.
Yeah, those are I like those pictures you got, Mike. That was cool.
Okay, so plug type doesn't matter. On to number 4.
I think you got that one. I'm running out of boxes over here.
All right. Oh, just one spark plug in number 4.
Nothing in there, huh? So one spark plug.
Higher compression boosted engines require higher kV. I mean, I think we kind of already know that this is confirmed because we've been messing around a little bit. We've seen it a little bit, but
yeah, and we've talked a lot about higher compression, raising kV. But what we're really kind of in awe about or wondering is how much. I mean, is it that big of a deal? I mean, if let's say you find the wastegate on your turbo and you hollow the hole out a little bit, or you just give it a little manual adjustment, or you take it off altogether, right? Or
manual adjustment of the wastegate.
Or let's say you put some high compression pistons in your car or something like that. Is it going to stress the ignition system to the point where you actually have to make a change, or is it just a very unnoticeable effect?
Well, think of like how easy it is to get extra horsepower out of today's cars with a simple tuner, right? You plug it in and all of a sudden you got 40 more horsepower on a turbocharged engine. You've done something different to create that power, right? So what are the negative effects of that?
Exactly. And then when we say high compression and boosted engines, I mean, this could be a turbocharger, a supercharger, and then with high compression, and think of it even farther than that. Anytime you change the timing of your engine, anytime you change the valves of your engine, the head, the airflow.
How it breathes.
I mean, every time you change the way it breathes or exhausts, you're changing the airflow, which can change the compression, which can change any of this stuff. And how much does it actually affect kV output?
I would think it affects it a lot.
And I agree with you, but enough to actually care though? Enough to actually make an ignition system on your ignition system different? I don't know.
Let's reset here.
Oh, here's a good one too. Liquid petroleum.
Oh, that'd be an interesting little test.
Yeah.
Okay.
We have to do that outside though.
So we have a factory gap spark plug in here. I think it's like 40-ish thousandth, 44 maybe. And we're just gonna run this thing. You know what? Let's just run it, and I'm going to manipulate the pressure inside of the cylinder.
Okay, so
I don't know if it really pays since we've been at this for a while. I don't know if it pays to do
yeah,
three
so
separate tests.
you're gonna start running it at low pressure, and you're gonna bring the pressure up.
Okay. So at low, let's grab some more time, and let's see a decent wave here. Maybe a little too much time. I want to look for consistency here and make sure that we're not trying to sample too much with the scope. So 11-ish. Now we have no pressure in the cylinder at all.
This is 0
right now.
psi. Okay.
Okay, so I was thinking it was going to time out. I'm really hard at figuring out what 30 seconds is in my head. Well, now it's just awkward. All right, let's try that again. 30 seconds. And I'm going to bring up the pressure.
Okay.
Oh, wow.
Wow. We're at about 40 psi now.
It's definitely leaking.
Is it the plug or is it the...
So that's 50 psi.
Holy cow.
Look at that.
Wow, that really changed kV. I didn't think it would change it that much.
Did the scope die? Oh, it shut off.
Okay, so this is about 100 psi. Interesting.
That is cool.
Wow.
Pressure is
You could just see the kV come down as the pressure left.
No,
I mean,
we're being pretty dramatic here with 0 to 50 to 100.
But I mean, I don't think that's that dramatic because if you think about an idling car, right? You have around, let's say, 50 to 100 psi. Sure. Snap throttle or going to full throttle, you could easily go from 100 running compression to over 200, 300 pretty easily. I mean, we only went up 100 psi.
In these slides here, there was a pressure spec of 1,400, 1,200 kPa. Whatever that comes out to. Somebody do the math quick. Hey, there's Eric.
Oh, there he is. It's actually 14 psi.
Oh, atmospheric? Is that
atmospheric pressure?
Yes.
Yeah. Oh, yeah, he did get us.
It's technically not 0.
And then for this gauge, we'll say it's 0.
0, which is calibrated at atmospheric pressure. So, unfortunately, this one was leaking a little bit, but I mean, this is a pretty easy one to confirm that higher pressure requires.
And it actually changed a lot more than I thought it would. I mean, we went from the 40s all the way down to under 10 with just releasing pressure from the thing. So
now,
yeah.
One other thing that we're not even talking about here, we're only talking about kV, but think of what cylinder pressure could do to the heat range for the plug.
Yeah,
if you
I guess
increase boost pressure or cylinder pressure through higher compression, pistons or something.
So you're making it hotter in the cylinder the whole time too, which is you're going to put even more stress on it.
You'd want to go with a colder plug then.
Wow.
So interesting. Unfortunately, we can't really test that aspect of it.
So, but I mean, I guess what we're saying to sum it up, if you change your car from spec and you put some boost in there, or you raise your cylinder pressures, or you try to use maybe even a different gasoline, or you change the fuel trims, you could be putting a lot of pressure on your ignition system. I've seen a lot of people just manipulate turbos and try to put 20 pounds of boost in something that maybe never had boost in it, just putting a turbo on a naturally aspirated motor, or even just changing, what your turbo was. That could be a huge effect on your ignition system. So,
and I think through our initial testing here, I think we could combat that with a slightly smaller spark plug gap, right? If our kV is going to go up because of our higher cylinder pressure, if we shrink that spark plug gap, in theory, our kV should go back down. So we can kind of combat higher cylinder pressures with a smaller gap. But at what point does the gap get too small?
Where you're losing your surface area to ignite your cylinder.
So you end up with that incomplete combustion event.
So then exactly. That's interesting. I think so far pressure has really been the biggest factor on this spark plug. Remember, we're not doing fuel and stuff like that too, but pressure has been the biggest factor on this thing, almost more than resistance and gap has been.
I think so too. I agree. Okay, I think it's time for another t-shirt before we get to the 5th option here. Should we do another number game, or what are you thinking?
We could do numbers go pretty quick. Could do another number.
Multi-strike ignition. That's a good point to bring up. So for those of you that
one.
aren't aware, some Ford vehicles and some Europeans, I think, are the only ones that I've seen it on, will actually spark or create spark or fire an ignition coil multiple times in one cylinder event. They'll do 3 or more
up to 3 times.
ignition
Yeah,
events.
a lot of Fords do 3-strike at idle. And
Yeah,
things
but
like
it'll
that.
only be a certain RPM, up to a certain RPM, and then after, let's say it's 3,000, whatever it is.
Yeah.
After that RPM, they'll stop multi-striking at that point because there's not enough time to charge.
Yeah,
the
there's
coil.
not enough time to get that coil charged.
But
Yep.
it's an emissions-related thing. They're going to strike multiple times to ensure they have a complete combustion event, that they've used all the air and fuel inside of the
Yeah,
cylinder.
exactly.
So great question with multi-strike.
Great question.
How does higher kV output translate to ignition coil life? Well, in a factory setting, the coil is designed to live the life of the vehicle.
So we would say, kind of like the test we did before, the higher kV is going to create
Increase
temperature from increasing voltage inside the coil. That hotter coil or a coil that's working harder is eventually going to get warmer more often and possibly cause the coil life to definitely degrade. I think that's.
Yeah.
I think we can all agree.
I think
on
we
that.
kind of answered that with test number 2, Eric. If you wanted to go back, we showed the effect of warm plugs on coils and how that could affect the coil's output and the kV and temperature of the coil. So, pick a number, or should we do something different? What do you want to do? You want to pick a number this time?
Yeah, I'll pick a number.
Okay, we're going to pick a number. We got 100 and what are we at right now? Computer is telling me we have 154.
154, okay.
154 people on right now, so a number between 1 and 154.
Okay, got it written down.
Ready, get set, go. All right. Who's going to get it?
2 through 154.
That doesn't count.
Oh, is
they are
it going
rolling
fast?
Hurting my eyeballs. Oh, don't want to get copyright infringement.
Oh, we're getting a little closer.
It is under 100.
Oh, there it is.
Glenn. I think Glenn was the first one.
Was it Glenn or was it Ozstars? It was 10.
That's Ozstar.
Oh.
Ozstar's Glenn.
He knows you personally. Sorry about that. We got 10. It was 10.
The number is 10. Glenn wins a shirt. Hopefully we didn't mess that one up. The chat rolls in so quickly.
Yeah,
guys,
it's coming in quick. Holy cow.
It is hard to see. But congratulations, Glenn, on winning your shirt. Email me with your size.
And if you want pocket or no pocket.
Right. Okay. Guys, on to the next one. We got 2 more to do.
Right, what do we got?
Resistor plugs weaken spark.
What the heck's a resistor plug?
Well,
or a non-resistor plug, I should say.
Every spark plug today,
Yeah,
pretty much every spark plug today has a resistor built into it, right? I mean, it's kind of a fact that today's cars require resistor plugs, right?
So all current cars have resistor plugs,
As far as
but
I know.
we should probably explain what is a non-resistor plug and why is that even a factor, you know?
Well, what resistor plugs really started coming into being common when computers started ending up on cars. So a spark plug without a resistor is said to create noise within the electrical system.
Okay.
Now, we're not talking about the spark plug yelling at us, but it's creating electrical interference
That'd be a whole other
in the
problem.
system if it doesn't contain a resistor. Most spark plugs, there are some anomalies out there, but most spark plugs are going to come with a 5,000 ohm resistor. You got that ohm meter over there?
Okay, let's
So we've
test
got
this.
a non-resistor plug and we've got a resistor plug. We're going to fire them side by side here, and just to confirm everything is right.
And we've kind of already talked to it. We know higher resistance is going to create a little bit weaker of a spark, but is it actually going to weaken spark enough to cause an issue?
Well, if we increase resistance, we're going to create an additional need for kV, which will lower our burn time, right? So in theory, I can't see it. What do
We
have?
got 1.6.
This is a 1600 ohm.
Something's
It's
not right.
open. What is our meter? Are our leads okay?
Yeah, leads look okay. That's happened before. We go through a lot of leads around here.
Well, I picked the spark plug here. That's like impossible to get to the center.
Let's see what we got here.
So right now what I'm doing, or trying to do, attempting to do, is I'm attempting to touch the ground. You want to get a close-up of this, maybe?
Yeah, I can do
Watch
that.
me messing around here, trying not to stab my fingers.
Yeah, if you do stab it, I kind of want to film it anyway, so.
Well, thanks. So we'll go, actually, let's just go to the shell of the spark plug and the center electrode. What does that say?
That is showing open.
For real?
I think we may have a resistor.
It should show about 5,000 ohms. Oh, I almost just stabbed your finger.
Oh, that would have been fun.
Better
Here, I'll show you the multimeter here.
I thought it'd be so hard to capture a resistance spec on here. I think it's these. Let's try a different one. Let's try this one.
Okay.
Dude, it's got to be these leads, right?
We've had some bad leads. Hopefully we've thrown these away, but.
You got that other multimeter handy? Where's that? You got that other one handy by chance?
Yeah, let me see if I can grab the other
Let me
multimeter.
switch you guys so we're not getting sick when the camera gets dumped
Sorry
over.
about that. Let me grab a different one. I think these leads were the bad ones.
So let's just throw those away right away.
All right, let's try this one once.
Come on, I'm not crazy. Hey, that looks better. 5-ish thousand. Let's go back to the plug we were originally going to do.
Okay.
What do we see? Seriously? That is wild.
Well, we know one's a resistor plug and one's not a resistor plug.
Okay. I guess we might just have to do one of these iridium plugs here. What do you got there?
Do you have to go to the wire connection? Thank you for that comment. A resident spark plug professional here is measuring.
I'm an idiot. So, to be fair, there should be an open connection between the ground and center electrode of the spark plug. Only happens live, guys. We are going to test our spark plug's resistance through the center terminal.
See,
so we're going to go.
I tested those leads before we started, but I wasn't going to say I didn't in case they were actually bad. But
We're going to go the nut of the spark plug where the secondary connection would happen and the center electrode.
and there we have our exact 5,000 ohms. Maybe close to exact.
Only when we're live. Fantastic. Now that is doing exactly what it's supposed to.
Okay.
Wow, that was a lot of messing around for me to look like an idiot. All right, let's try this again. Non-resistor plug this time.
Okay. And that
Should
thing has
be
it's like no resistance at all.
0.5, half an ohm.
0.71 ohm. It's jumping around, but that's no resistance at all.
So no resistor plug. They are legitimate.
Just a little bit of time to prove it to be ready. We're supposed to
boy.
know. So
That was okay. We're gonna fire these on opposite ends of the spectrum. You want the resistor plug or non?
I'll take the resistor plug. I have the or the non-resistor plug, I should say.
Non-resistor.
I have the least amount of sensitive electronics on this side.
All
so.
right. So we're gonna fire these with the. Oh, this one's got a larger nut. Of course it does.
Just that should be good.
Spark plug wire.
Okay, so
Spark plug wire. So really what we need to determine here is, well, first of all, does the resistor plug
change the KV?
Change KV.
Okay, let's get some
We do have a
power in.
paddle probe as well that we can try to see if we can pick up some noise with. I'll get the scope set up. Paddle probe is going to go on which channel?
The paddle probe should be on channel 4.
Okay, so we're going to use a secondary ignition pickup paddle probe. And there it is, a coil unplugged paddle probe we'll have on channel. Did you say channel 3?
Channel 4.
Channel 4, I wasn't actually
We had
listening.
the amp clamp on channel 3 before.
That's right. Okay, channel 4 is our paddle probe. And there we go.
And Just to confirm, this is the non-resistor plug?
So you got non-resistor, I've got resistor, we're hooked up.
Okay, we need to get some kV leads on here.
So we'll put...
This would be, so I'm going to have channel 2, or the red trace, on the non-resistor plug.
And then the blue trace will go on the resistor.
Definitely want to get a ground on here. Okay.
I think we should be good.
I think we should be good too.
Okay.
Are you ready?
I don't know. We're about to find out.
Ready?
Yeah, let's see what happens, I guess.
Okay, we're firing 2 plugs. What do we got here?
Oh, we've already...
Ooh. 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 Ooh.
Let's do that. Let's do that again.
So it looks like we're getting some pretty bad interference actually from this thing.
Did the stream drop? The stream is still up. Okay.
Okay.
We'll try that one more time.
All right.
I got the USB cable away from the plugs a little bit here.
All right, you ready?
Yep.
Oh, it's
that
dropping.
Camera flickers. It freezes the scope.
It's freezing the scope actually. That is interesting.
Okay, do it once more. I wanna save it here and hopefully
okay. We're hoping the stream doesn't drop out. This must be a lot of interference coming from this thing.
Did you guys see that?
It just turned the light of the drill on that's laying on the table here. No one touched this for a while here, and the light just popped on the drill from. There must be some magical interference going on here. Wow.
Surprisingly, they don't look all that much different.
So, yeah, there's not a big kV difference, but there's definitely some interference coming on this non. One thing you guys didn't see, it actually dropped my camera out off of our other screen here, and it turned the drill light on by itself.
It froze. Oh, I'm zooming.
And it looked like it froze the lab scope a couple times.
The scope. So our burn time on the resistor plug is at about 1 millisecond.
Okay. Okay, so it definitely changes the burn time.
So we get a longer burn time with a non-resistor plug, which is exactly
what we thought, right? Yeah, less resistance. It would be smaller kV, more burn time. One thing I did not realize is how much interference must actually.
Let's just make sure that we don't have anything hooked up wrong. So we got right now the non-resistor plug is unhooked. Fire this thing up again and let's just see.
Let's see if we have any dropouts.
Yeah. Make sure we don't have anything hooked up wrong.
All right, you ready?
So no flickering on the camera.
No, the camera's still on. The camera's not going off. Okay.
Scope looks good. Wow, that is wild.
So I guess it's pretty safe to say that the resistor plug definitely affects the kV. That's going to affect the burn time, but I think the biggest thing we just uncovered here is
a massive
amount of interference from the non-resisted plug.
To the point where it was making the scope mad. It turned the light on the
drill. It cut the camera. The camera went black. Actually, this point and shoot actually went black. It's working again now, which is good.
That is wild.
That is interesting.
So I did find this chart here that shows the noise level compared to or over frequency with resistor and non-resistor plugs. That is just wild.
Wow. So there's definitely some more noise. And remember when we say noise, we're talking about EMI or electrical magnetic interference or something like that.
Enough to mess with the lab scope and the USB cable.
So what's our consensus is, we were weakening spark. That's what we were talking about, right? So yes, it definitely weakens spark a little bit.
So resistor plugs weaken spark.
But more importantly, if you do not require a resistor or a non-resistor plug or whatever, don't put one in your car. This could really definitely cause some issues.
I mean, if you're running a computerized vehicle with PCM, ECM, even ignition control module,
and
you could be causing massive issues with a non-resistor plug.
With all the modules in cars today, we hear this all the time, but you rarely see it. EMFI can cause all these issues. And thinking about what this just did to the electronics we had here, thinking about putting 8 of these in your car and firing them, I mean, this could shut your whole car down. This could cause your whole car to have massive amounts of hard to diagnose electrical issues. Radio noise was like, I seen someone say radio noise. I'm like, that's the first thing I was thinking, like a little radio noise, maybe a little bit of buzzing or something. But watching my camera shut off and that light just pop on, I'm thinking this thing
That's crazy.
This thing might do a complete catastrophe to a car.
Somebody needs some tinfoil lined underwear, they said.
Yeah. I seen the scope dropping out and I wasn't sure that's interesting.
Yeah.
All from just a plug that.
Okay.
All right.
So, I mean, confirmed, resistor plugs do in fact weaken spark slightly. Slightly require more voltage.
But the myth that we
gap.
didn't test that I'm more concerned about now is the noise that just came off of this thing.
For sure. Okay, on to the last one.
All right, so we have one more.
Should we give away one more shirt?
Let's give one more shirt quick before we get to the last one.
Okay. One more shirt, guys. We're going to do one more. Pick a
One more
number
shirt.
between, we're at 160 right now.
What we got here?
Let me write it a little bigger.
Oh, I wonder if he's changed his mind.
I did change my mind,
He
actually.
changed his mind is what he
Okay,
did.
can you see it?
Okay, I got it.
All right, number between 1 and, it was at 160 when I looked. Doo-doo. Oh, I gotta stop doing that.
They're coming in quick now. Oh, there it is.
There it is, Neil.
There it is.
Neil
It was 42.
Robbie.
42.
42 is the number.
That one went quick. That was good.
That was good. Neil, did you snag my email address early? Actually, you know what? I'll just.
Let's throw it in there again. Remember, not only size, but we need to know what type of shirt you want. We have pocket and no pocket.
There's the email for you guys, for you, Neil. Shoot me out an email with what Ryan just said. Okay, on to the last one.
We have one more, right?
This one is going to be the most controversial. Performance coils are better. Now, we intentionally put the word better in here because better is vague.
And when we say performance coil, we're saying vague too.
Better. I like the word better. So better aesthetically.
I think aesthetically they're always better. I mean, they're pretty, right?
So-
But I'm thinking more of, in all cases, is it always better to have more of a performance type coil?
So we have a OEM. We have one of those coils that you can buy out there on special for basically like 8 of them for the price of one OEM. And then we have a red performance coil
type
here.
coil.
It's definitely pretty aesthetically.
I mean, it
it's
definitely
better.
looks nice. I mean,
But people aren't. Some people might be buying a performance coil for the looks, right? The underhood look on their vehicle.
and we really can't test longevity either, so that test really isn't going to come into play. But what we're thinking about is a performance coil better to install all the time? Is there a time to install a performance coil? And is performance coil going to put out more juice, right?
Yeah. So we should probably measure a couple. We might have to do a couple different tests here to really.
Well, first let's just fire. Let's fire them all in the chamber with the same plug, same pressure, and see what we get.
I really want to see and if there's any amperage difference.
Yeah, that's a big thing too, right? Because you would think performance coil would probably draw more amperage, put out more power.
Maybe.
So let's start with, let's do that.
Okay, let's do a little baseline testing. Actually, let's lay out the test quick.
Oh, I love the
So
comments.
we have OEM. We have let's just
value.
call it value.
There we go, value
and then
coil.
Let's call it
Upgrade. Just call it upgrade.
upgraded.
Possible upgraded. And
sure.
take this with some of this with a grain of salt. We're not testing every upgraded coil. We only have our hands on one, so.
KV, burn time, and amperage.
Yeah, let's do amperage. That'd be a really good test.
And now we could really, I think we should run this in a factory spec gap, and then I think we should also stress it by.
Yeah, because I think we should
wider
probably
gap.
let's do a factory gap and then let's do a really big gap because we want to stress this thing out to see if it's worth what we need it to do, right?
But we
or
can't-
if it's going to do more.
We can't really measure. It would be really difficult to measure the amperage on here.
So let's run it. Let's run it in here though, and let's just run it.
Let's do a baseline here.
Let's do a baseline here, so we're
Yeah.
not using pressure anyway.
Yep.
Good idea. Okay, do you have a plug in that box for this? Or we can just use one of our many new plugs here.
Well, we've kind of got a mess here.
Let's just not run that non-resistor plug again. I don't think the electronics can take that any more of that.
I've got 2 of the same here. You gotta. Can I get that gap, or they're different gaps here?
Here you go. And I'll get these out of the way.
So we're sitting on a 40,000th gap here, and we'll fire each of these coils in atmospheric pressure, 14 psi according to Eric.
Liquid cooled. That would be
what's
interesting.
liquid cooled?
If there's a liquid cooled coil, I haven't seen it. It sounds cool.
Sounds like a problem.
Oh, okay. Maybe like an old oil coil. Yeah, okay. Old school stuff. That makes sense.
Okay. That one's snug.
Oh, we got some good comments. You guys are all on point here.
What's going on?
Adding a turbocharger, supercharger. I mean, right? If you're adding more pressure that you need, if you need a longer rope, get a better coil, right?
Dang it.
What are we looking for?
A nut that would fit. That's okay. We'll do all 3 coils on this guy right here. Okay.
Yeah, we'll just. So what do we do first? Let's start with the stock.
OEM.
Okay, let's get this.
Wait, we can't measure kV that way. We gotta go like this.
Yeah.
OEM coil.
I still can't believe that drill lit up.
I feel a little bit different now,
Yeah, right?
Let's grab amperage on that as well.
Good idea.
I'm gonna shut off the 4th channel. Yeah. Okay, let's go.
Let's try to get some of this out of the way here.
So again, we're just firing into atmospheric pressure here, so I'm not exactly stressing the coil, but this will give us a baseline that we can really quickly change between.
Are we grounded here? I want to get that off of there. We're grounded?
Yep.
Okay, we should be good to go.
Go for it.
Okay, something's. Oh, okay, never mind. You're zoomed in. I was like. Amperage. Oh.
Want to flip it?
Yeah, it's easier. You can do this here. There we go.
Beautiful. Okay, you can shut it off. We'll record a screenshot for each of these. So our kV output measures in at about 10.5. Our amperage measures in at a whopping 9.19 amps.
Wow.
And our overall burn time is roughly 1.12 milliseconds. So 9.19 amps.
Good question with the difference in coil resistances. I did measure all these coils before we started, and they all are actually really close to the same resistance. And by close, they're all very close, like within like 0.01 resistance, which is interesting too, by the way.
5. Okay. Beautiful. Next.
Okay, so that was the OEM coil. This is a very cost-efficient coil.
That's one way to say it.
If it fires, man.
Spark is spark. If it fits, it ships.
If it's in stock, it's installed. So we got time to wait, right?
All right.
I think we're good. Let me just double check this. Yeah, we're good. I may or may have not made a mistake when we were doing some testing before. You ready?
Yep.
Okay.
So that is interesting.
It's got a pretty clean amperage draw, actually.
Yeah, but
I mean,
it's only 6 amps.
It's only 6 amps? And what was the other one?
9.
Wow. The other one was 9?
9.
And this is, okay.
Not to be confused with no.
It's not conserving its energy?
What the? That is wild. We're firing on the same spark plug.
We have all these settings are the same. I can't change it. Well, I could change this, but I haven't changed it. So it looks like this one is put, and it's weird. What's interesting to me is it had the same primary resistance in.
Let's confirm that quick while I'm typing this in. You want to show them that? Because that's I'm stuck.
Because it had the same primary resistance, and it shouldn't be changed too much here. Let me just make sure again.
800 and so.
I'm hoping the heat isn't affecting this too much now, but.
What was the kV here? Interesting. 8.7. What?
Oop. Okay, so this one is 0.7 ohms, and that's what I got before.
So that's the OEM.
That's the OEM.
So this is interesting. The burn time is shorter and the kV is lower. And, well, I guess that makes sense. The amperage is lower.
Yeah, it seems like it was, but it's interesting. I want to do this primary resistance again. Different kind of wire, maybe?
I don't know. It's kind of cool to see.
Yeah, this is measuring at 0.72.
So same resistance spec.
Same resistance spec. And
right.
that's very interesting. And this was the budget. Okay, yeah, I guess. Go big or go home, right? Let's see what
Let's see what happens.
See what the red one does.
I guess not the results that I was expecting to see initially here.
I was expecting maybe a little different, but
Oh, good old school ignition scope.
I know some of these Ford coils too will use a little bit of like noise suppressing material inside of them. It could be different between noise suppression on these coils. I mean,
Use OEM coils on stock engines, performance coils on modified engines? Maybe. I don't know if we can make that determination yet. Okay, we're good? No?
No, or that's not the right one. We got to get the. There we go. This one will have no output.
All right. Okay. We're good?
Are you ready?
I think so. We'll go close up on that.
Do we get 2 secondary wave patterns?
I think that might just be noise on this one.
Okay. Let me know.
All right, you can shut it off. So now we are pulling
What do we got on this one?
6.8.
8. So that one's kind of like right in the middle.
Our KV requirement on there is, or our KV required to jump the gap,
Okay.
14? 14?
And it's interesting because that shouldn't change.
6.8 and 14. So 14K and 6.8. Now the real question will be burn time, right?
Yeah,
What
definitely.
is, I'm glad I documented these because I would have forgotten all of these numbers by now. Interesting, the burn time's kind of interesting looking here. So just under a millisecond, 925.925. Huh.
That is interesting.
So at 6, can we run that OE coil one more time just to make sure it's
Yeah,
not
let's run it
anomaly?
again. Let's just see, just to make sure we're not. See if that amperage was really
Yeah.
what we thought it was supposed to be here.
That's a. It seems
OE coil.
the OE coil seems like an anomaly at this point. Everything's good, and these are the same. And just to be clear, I don't know if we mentioned that, but these are the same exact ignition coil for the same vehicle.
So one thing I want to note too is switch to the other camera lens quick.
Oh, my bad.
One thing I want to note too is the boot is pushing on the tester farther on different plugs, which means the springs can be different.
Oh, the distance.
And like I was talking before, sometimes companies will put these little
The ferrite rods.
ferrite metal or rods inside the springs, and that's for noise suppression. So that is what could be changing the secondary KV and changing the burn time directly. It might not be the primary resistance. It may be how much protection or noise protection is built in, because we've really discovered how much noise affects things. So
Yeah.
all right, let's try this again. Here is the OE again.
All right.
Let's make sure everything is clipped on there. Ready?
Yep. Boy, that is
And,
not an anomaly.
I mean, that's not an anomaly. We're getting, I haven't moved anything else.
that is just wild. What a difference.
We're still at that
Oops.
high amperage. You got that
90.
pause?
Longer burn time. All right. Not an anomaly.
So
Interesting.
each one of these things had the same primary resistance, but drew a different amount of amperage, had different KV output, and different burn time.
Wild.
So I guess we would say that's not even really our question. Our performance coil is better, though, was our question, right?
Yeah. Let's hook that up to here. Let's run this thing under pressure. I want to get a different plug in here because I want something in the gasket. Let's stress these a little bit. Let's throw them under pressure and
see. Let's see if they act the same way when they're under pressure. So we won't even have to change the gap. We just have to put some pressure under
We're
there.
not fighting that strange one. What do we got here? That's a normal looking one, normal gap.
Okay, so what do you want to start with? You want to start with the OE one?
Yeah.
Okay.
Okay, so now we're going to do the same test except under pressure.
Okay, I'm actually going to take this off of here.
Click. Okay.
That on there.
Seems a little wonky, but I think it might work. Can we maybe...
I don't like that
Need
being
like
so
a-
close to the amp clamp, but okay.
See if we can insert some cells here and do... Hey, look at that. PowerPoint Pro.
There we go.
Woo. Okay. OEM.
Okay, we're just going up to about 100?
Yep.
Okay.
100 PSI. Okay.
So this is the same setup, except now there should be a lot more load on the
Our
spark
KV
plug or
should
the
be
coil
higher.
because we have such much pressure in here. So, oh, we got nothing. Oh, is this grounded?
We're grounded.
Okay. What do we got changed here? Is your scope running?
Let's actually have the scope running.
When I don't see spark on the scope, I'm wondering where it's going, and I don't want to be the precipitant or whatever of the
You don't wanna
spark, so I'm
receive it.
shutting it off. All right. There we go. Now we're cooking.
Cool. All right, that's good enough. So amperage, I would imagine the amperage should be about the same, right? Because we haven't changed
Yeah.
the on time or the charging time of the
And
coil.
that's one thing we kind of talked about before too. The demand shouldn't change the amperage. Amperage is always going to be based off of Ohm's law, the resistance of the primary and the on time.
So the only
of the coil itself.
the only effect of loading this thing or putting stress on it should be the
KV.
KV and the burn time. We should have a higher KV and a shorter burn time.
And then the heat that's
So-
produced, obviously, from the higher KV.
Sure. 34,000 volts.
Wow.
And our burn time
34,000 volts, that's a lot.
is now 800, we'll call it 800 milliseconds. So 9.3 amps. 9.3 point, what did I say? 0.89?
I believe so.
0.80 milliseconds.
Okay.
And KV was 34,000. Okay.
So, yeah, I mean, pretty good. I mean, the OEM coil put out 34 kV, we still had almost close to a millisecond of burn time. I mean, that thing stood up pretty good.
Okay, let's swap out that coil.
All right, so what are we doing next? We're doing the value?
line. And now I'm going to swap out the air that's inside of the cylinder because we're starting to build up some ozone inside here. We want to make sure that we're running consistent tests, the same test.
What I've noticed with this aftermarket one is the boot goes on pretty easily, or goes on all the way.
Sorry, trying to swap the air out in here.
No worries.
All right, pressurizing.
Okay, we should be ready to go. Don't forget to press play this time.
Oh, it's running. Fire in the hole.
Ooh, a little erratic. Okay.
Okay.
All right.
So this time our amperage is at, let me just,
And it should be the same. I mean, should be.
7.8 amps. That's higher.
That's higher, which is interesting. Very erratic.
7.8 amps and 640.
640.
7.8 amps, 600.6 milliseconds. So
Okay.
I said 7.8, weird. 0.64 milliseconds.
One thing that could have, well, I mean, that's interesting too, that it created more. I thought maybe it would have heated up a little bit. It would drop the amperage down a little bit, but that's interesting.
And our KV is 41,000. Strange. Okay, one more test.
I mean, what if it's showing anything? It's showing that the coils are keeping up with the pressure at least. So
At least
that's
for,
good.
for
I mean,
this short amount of time.
none of them have failed under this pressure.
All right. Pressurized. Change to the winter air. Oh, they're talking about rental cars.
You know what I think would be kind of cool too, if you could charge this with maybe just nitrogen and take all the oxygen out, or some other inert gas, and see if different inert gases would change it.
That'd be interesting.
I mean, explosible gas would be fun too, but not in this chamber.
Yeah, not here.
Are you ready?
All right, ready.
Wow.
Alrighty. Hello?
Where's your blue channel?
I don't know. Where'd you go? You want to turn it off for a second?
Yeah.
Something
Try to get that again here.
ain't right. Let's try that again.
All right, there she is. Ready?
Yep.
There we go.
That looks more normal. Okay. So we'll start with amperage again. We're pulling. Get you out of the way.
About 6.8.
6.7, 6.7.
6.7, 6.8 amps.
Okay. 6.7 amps with a 740. So that's pretty consistent.
That's pretty consistent.
Burn time went down.
Oh yeah, the OEM was pretty consistent too.
Agreed. And then our KV should be significantly higher.
And these are just 3 random coils too. There's so many different different brands of every single.
Yeah.
There's different aftermarkets, different performances. This is just 3 random ones we picked out. So.
Well, I mean, that's pretty messy here to look at, but
I think the most interesting thing to me is that they had the same primary resistance, and they didn't have the same numbers under pressure or out of pressure. I figured that they would be more closely related with the same primary resistance, and that really wasn't the case here.
interesting. That's really interesting. So,
and it looked like the OEM did a pretty good job too. I mean, that was a lot of amperage getting pulled by that OEM. But back to our question. I mean, what was our question? Are
they better?
performance coils better?
I mean, I would say that this performance coil, this red coil here, is performing as
needed.
as
I think they all were performing. I mean, if you think about some of the KVs we hit here, they are pretty high lean KVs. But I guess our biggest question wasn't are they better? Like, is this one better than this one? Is this one better than this one? That really wasn't what we were trying to find out. Or maybe
what do you
for this
define
test,
better
what we're
as,
defining is it always better to put a performance coil in your car?
I like the consistency of the OEM coil and the performance coil here. I like that they're both doing this roughly the same thing that we would expect them to do. That value one there that we threw in the middle, it bothers me a little bit.
It may be, but I mean, it's a good price too. I mean, my biggest takeaway from here is, do you need the power or do you not need the power, right? So if we go back to, do performance coils matter?
Like on a stock engine?
Like we're getting a lot of good comments here. I mean, if you're raising your KV, you make your gap bigger and you're putting more pressure in the cylinder,
increasing boost.
I mean, these coils, not even aside, any coil, you're going to make sure you want the coil that can put out get your rope as long as possible if you need that much rope. Maybe if you had a very stock engine where you're only running it under normal circumstances, I mean, think of it like a rope for a boat anchor. If you're always fishing in a 20-foot lake, you don't need a 500-foot rope on the end of your boat anchor, right? So,
but some people like to say that they have a 500-foot rope. Sometimes it's a status thing.
So it really, if you need it, and if you don't need it, you're just kind of wasting it.
But if the coil is able to output a higher voltage value more consistently, in theory, it should be able to handle the temperature.
Will it stay cooler too?
Right.
Because it'll stay cooler because it's not working as hard.
Right. It's not. So if the coil's able to put out this much voltage in its working life, if it can do this much, is it going to be cooler overall? A cooler working coil?
And we have a good question here too. Just hope it lasts longer. That's one thing that we can't test here either. Is a coil that's working harder all the time? Is that might fail faster than a coil that's not working as hard?
Well, if you make a component work at its peak performance constantly,
peak performance,
it's going to fail sooner than if it were having to be lazy and not have to work as hard. So,
but performance coils better, and I guess in the question of all the time, probably not all the time. But if you need that extra spark, like you're saying, if you're going to make changes of your engine. You're going to boost it. You're going to make that harder or work harder. Yeah, I think you have to get the best performance coil you can. So yes, performance coils are better for that aspect, but always better? I don't know.
It depends on how you as the individual, either vehicle owner or person working on the vehicle, it depends on how you define better, I think. And I think Keith asked that question in the chat, what is better? How do you define better? For some people, better is just simply it looks cool, right? It's red or it's yellow or it's whatever other color.
And that, that may, for my stock engine in my car, I could care if it was purple, pink, red, or green. It doesn't matter. But, if you spent a couple grand getting that engine painted with those chrome valve covers and that thing looks pretty, everything's painted, you maybe want something, something to look nice there too. So,
exactly.
I would say this is a plausible.
Yeah, I would say plausible, or I'm going to put it in the middle between plausible and confirmed.
And I'm taking this not just off the test of the coils that we use today, because we just did 3 random coils. There's a lot of different brands, there's a lot of different coils, there's a lot of different types. So it's definitely plausible, and they definitely have their place when they need them, when you need them for your car.
Yeah, definitely.
A split fire.
Split fires. Keith's question: are NGK spark plugs rated as standard life and long life iridium? I'm not sure exactly what they're marking them down on the on the marketing stuff. My guess the difference would be in the electrode material. If the ground electrode is going to be running a precious metal, I would say that would seem to me like a long life iridium.
Yeah, and I can't stress enough that all the tests that we did today were based off of just air under pressure, lean conditions. In an actual engine, you're going to have so many different variables that are going to come into play that can change things, whether it's the way your fuel is injected, if it's direct injected, or if it's coming from a carburetor, or if it's a port injected, or the fuel trims you're running,
the density of the air in your area,
the compression, everything like that too. So, but the core fundamentals we learned today are invaluable when you're actually thinking about an ignition system on your car.
Right, and we were able to consistently show the variables across the board of all our testing.
Definitely.
Let's go through the checklist. Spark plug gap matters.
Confirmed.
Confirmed.
That's confirmed.
I agree. Worn out plugs kill coils.
That was confirmed.
Confirmed. Plug type doesn't matter.
That was busted because he tricked me on that one with the way he wrote that question. God, like an ASE test. That's just like an ASE test.
Tech A says.
Got me.
Cylinder pressure, it does require more kV. Resistor plugs, well, they do in fact weaken spark slightly. They do require a higher kV and reduce burn time. The other effects.
Watch out for that noise. Wow.
Yeah.
It's amazing because spark plug wires have resistance built into them.
I think at the time of the engineering of the ignition system on the car, they take all that into account, right? If the spark plug wire is going to run X thousand of ohms per foot and it's got to run 3 feet, they're going to plan a coil accordingly at the OEM level to make up for that high secondary resistance it's got to overcome.
What's interesting to me too, though, is like even the gap is going to be resistance. Just adding that resistor in the plug, I didn't think would make such a big difference on the noise that came out of it. Because the light, the camera, and everything. I'm like, so yeah, be careful with resistor plugs, even if you have plugs, any kind of technology in your car. I'm interested if any of you hot rod guys that are running all non-resistor plugs, what your cell phone's doing while you're driving down the road, right? That's interesting.
Keith says when we ran that test, the Saturn in Oregon stalled out with a cam sensor code. That's a possibility.
Ion sensing technology. That is great.
Does that Saturn, in fact, have a cam sensor in it?
Yeah.
That is the question.
That's how you get the new guys. It needs a cam sensor. Ask, see if they can find it, right?
All right, performance coils are better. I'm gonna say confirmed, because it depends on how you define better.
A true performance coil is better, but are they better from another coil, or are they better in every situation? Is that's how I interpret it.
Are they better on a stock engine? The stock engine doesn't require the additional output that they could do, but it was consistent in our testing. I'm putting that there. It's confirmed.
I'll move it later. I'm sticking plausible, but we're fine there.
All right, guys.
This has been fun.
Holy cow, it's been over 2 hours.
Whew.
Time flies when you're doing
Yeah.
Mad science.
I mean, it's fun to play with all this stuff too. Hopefully we didn't break any of it.
We do have a mess here to clean up. Now, I did want to mention congratulations to our T-shirt winners.
Definitely.
You guys, make sure you're getting me those emails out there for those. If you haven't been around the GoTech channel in a while, make sure to take a look around. We've posted a lot of new videos, and we're also out on the other socials of the world now as well. So look for GoTech on Facebook, on Instagram. We even have been starting to do TikTok videos.
We're trying. And we got a lot of fun stuff coming out. We've been working on stuff. We've been wrecking our brains trying to see, you know, what can we do next. This was a blast to do too. I mean, like, what can we do? What can we do with a spark plug and all these spark testers? And I don't know, it was fun. I had a good time.
Thinking back to the last time we did a live class here, I didn't have all this gray hair up here.
I think that EMI maybe put a stripe somewhere here that I might see later. I don't know.
Here I thought maybe it was just getting you up to speed over the last years, giving me some gray hairs. You know? All right, guys. I think that's gonna about do it. I did want to mention one thing. The Train by Tech guys are doing a live discussion after dark tonight. So if you want, head out to their channel, check that out. Go hang out with them at 8:30 Central. They're doing that.
That sounds cool. I'm going to check that out myself.
If you're looking for more training, there is a huge in-person training event happening in Kansas City that we'll be heading to at the beginning of March. It's March 2nd through March 5th. Just Google Vision Kansas City.
Yeah, filled with some of the best trainers around the world. I mean, guys that are way smarter than us. So it's going to be awesome. I'm going to be there. I can't wait. Yeah.
So what is that? 2 weeks, 3 weeks away. So Vision Kansas City. If you're looking for some awesome high-tech training for that. Let's make sure there's nothing else going on in the comments. Did we miss anything? Is there anything critical that we cover while we still have you guys in the comments? I don't want to leave anybody hanging.
And if there's something you think about later, just put it down there, and we'll make sure we check these things and get back to you guys too.
Yeah, we'll definitely respond in comments after the video. Omnipresent Keith.
Good to see you, Nick, as always, too. Nick, we love the support that you give us all the time.
Thank you very much. Oh, one more shirt. Should we do it? What is that? 1, 2, 3, 4.
You're writing these down, right?
No.
We're going to have to go through and figure that out.
Well, we'll have 2.5 hours of video to scrub through, but
yeah, we'll be fine.
All right, one more shirt.
One more shirt.
You want to do this one?
I'm doing it. What do we got left?
Says we got 72 people
72 people hung around. All right, one more shirt.
One more shirt. One more shirt.
Okay. Here it is.
Oh, now there's 127 people. What the heck?
Here it is.
All right, the number's locked in. Start your guesses.
Start the guess. Oh, we got it already.
No way.
It was 36.
No way.
Did I show it on camera?
Keith is truly omnipresent.
He is. He's been on all day, man.
36 was the number. Congrats, Keith.
I went right in the middle. I thought like someone's going to guess right in the middle of 72, and he got it.
Congrats, man.
Awesome.
That's awesome.
Congratulations.
All right, guys. I really appreciate everybody sticking around. We've had fun today. I hope you guys have enjoyed this.
And thanks for all the support I've gotten recently from being new to the channel and the new videos I'm learning. It's been a process and it's been fun. So thank you.
Let us know down in the comments if you guys like this format. We can continue this. We can find more things to
Yeah, I mean, this is fun for us too. So
we've really enjoyed this and appreciate you guys sticking with us. So again, let us know in the comments below. Hit that thumbs up. Subscribe if you haven't. Head out to gotech.com/sign up to get yourself on our mailing list. So that way, when we're coming out with new stuff, you get an email.
We got a lot of good stuff in the works too.
So Kevin, make sure you're signing up for that mailing list so I don't have to send you a message before we go out live, okay? Save me a text. That'd be nice. All right, gotech.com/sign up. Comments down below, thumbs up, subscribe to the channel. I think we've got everything.
Yeah, I think that's everything.
And if you guys are going to be in Kansas City for Vision, we'll see you there. Until the next video.
Yeah, thanks for watching, guys.
Thank you very much, everyone. Have a good day. Happy wrenching. Almost missed that one.
That was fun. That was fun.